Good evening, all. Let us start the session. First, let us welcome our resource person, Dr. Mahesh Udar. He is currently working as a professor in government first grade college, Hukeri. He obtained his PhD from Vishveshwaraya Technological University, and he has in his field he has total 17 years of experience. He published more than 15 international journals. Among them, he published his papers in reputed journals like International Journal of Multimedia Information Retrieval, Multimedia Tools and Applications. Both belongs to Springer publisher. uh, and his area of interest, that is his key skills are data science, artificial intelligence programming, and machine learning algorithm. Today, sir is going to engage you people by taking the concept, that is agentic AI. So I hope you are going to get a benefit from this. Mahesh sir, Mahesh sir.
Hello, sir. I'm
Yes
audible.
sir, yes sir, you are audible. You can start the session now.
Shall we start or shall we wait for some more time, sir? Because only 66 people have joined till now.
Okay, sir. We can wait 3 more minutes now. Okay, 3 to 5 minutes.
Okay, sir. We will start exactly at 6 p.m. sir.
Okay, sir. Okay, fine. Thank you, sir.
Hello, hi, sir.
Yes, sir.
Shall we start, sir?
Yes, sir. Please start, sir.
Okay. Before I start my session, first of all, a very good evening to one and all who are uh, joining this meeting. Second thing is, I would like to before I start this session, I would like to thank the organizer for giving me an opportunity to share my ideas. I will be having two sessions in this FDP. This will be the first one. I think mine will be the last session in this FDP. I don't know exactly. I think 13th or 14th session is there later. So in this session, I have been given a topic called agentic AI. This is the area or era in which we are living right now. Being the computer science people, we must have seen a lot of eras like core artificial intelligence. It has later. emerged as a machine learning, then deep learning, and then generative AI. And then right now we are in the era of agentic AI. So what I will be doing in this session in next 90 minutes is around I'll be talking about the few concepts about agentic AI, and then the main point what I wanted to discuss is how can we do the implementation of agentic AI systems? Like how can we design simple agents, or how can we design multiple number of agents or something like that? That is what I wanted to do in this particular session. So I will go through this uh, AI evaluation. Yesterday I have attended the session from I think Ali sir. He has already explained what is the evolution through which AI has gone through. I will briefly touch upon all these things. I will not be going in details about AI evolution because we have already seen the yesterday's session. Later, we will discuss about what are the differences between generative AI and agentic AI, because there were many myths around it, like both of them are same or something like that. So we'll try to touch upon these two things. Later, we will discuss what are the design patterns of agentic AI, and then we will discuss about agent architecture and design. And finally, and the main part of our today's session is how can we design agentic AI systems. I will take some examples and then I will try to build in front of you like very simple examples, like how to build an agentic AI to do assignment evaluation or something like that. I will try to build in front of you. So this is what the core contents of this particular session. So first we will start with AI evolution. I said earlier, I think yesterday also you must have seen, and we have many of us know this particular thing. Like AI has evolved from variety of eras. It has started with a rule-based artificial intelligence. Since 1960s to 1990s, this was the main era where we have only explicit logic, if then kind of rules were there, and the limited adaptability was there. For example, the rule is like if a particular student has scored more than 40% of marks, then he has passed the examination. If he has got less than 75% of attendance, he is not eligible for examination. Such kind of if then kind of rules were there in the earlier artificial intelligence system. When we design a game, let's say that a particular opponent has played a particular move, there will be a rule for the computer to play the next move. So that was the kind of era was there from 1960s to 1990s. In the second era was like machine learning, which was started in the 1990s till 2010. Almost everyone was talking about machine learning. In machine learning, we don't have anything called as a rules or something like that. What we have in this case is we have a data. The data is in both, like examples were there, as well as we can say that the labels for each and every example. So that data was given as an input to the machine learning algorithms. The algorithm will find the pattern among that particular data, and then it will design some models. It may be a classification model or predictive model or something like that. We have seen a lot of algorithms. Maybe you must have heard decision trees, support vector machines, and so on. So all these algorithms, what they do is they will find the patterns among the given data from the you can say that examples, and then they will come up with a predictive model or a classification model. So later, what we can do is we can give a new examples, and then we can predict or classify the new example into one of the classes or something like that. But the problem with this machine learning algorithms was it needs a structured data, and here we cannot give textual information directly. What we need to do is we need to convert the textual information into numerical tabular kind of data, and then we need to feed that data as an input to the machine learning algorithm. So that was the problem, and we cannot use this thing for uh, kind of you can say that we may not be able to get quite a good accuracy with these kind of algorithms and all. Later, the next era came into picture is the deep learning, which was started in the year 2010s till 2020. the era of deep learning. Here, what actually we were able to do with the help of deep learning is we were able to do like image recognition, can say that the speech recognition, natural language processing, all of these things we were able to do efficiently with the help of these kind of algorithms. These algorithms were having multiple number of layers. Each of the layers will be doing a lot of tasks so that we can get the better results at the end of the day. The problem with these kind of algorithms is they need a huge amount of data. That data will be fed to the algorithms, deep learning algorithms. We were having different kind of algorithms. We have started with ANN, artificial neural networks. Later, convolution neural network came into picture. After that, there is something called as recurrent neural networks came into picture, gated neural network, LSTMs, and so on. So the different algorithms were evolved for different purposes. For example, if you want to do image processing and all, CNN was used. Whenever we want to do something like you want to process sequential data, in that case, we can have to use recurrent neural networks. Whenever we want to remember a lot of information from the past, in such cases, we were used LSTM and so on. So based on the different use cases, we have used different algorithms. So that was from 2010 to 2020s. As said earlier, the difficulty of using this one is the huge amount of data was required. The second thing is the computational power. We were not able to execute these algorithms on the normal CPU and all. Of course, we can execute it, but it will take a lot of time to train and all. To avoid such kind of things, definitely we have to use graphical user GPUs and all. That was not affordable for everyone and all. So that's the reason. That was the one problem. So, uh, and then the next one is something called as a generative AI came into picture, which was from 2020 to 2023. This is the place where many of us, not only the computer science people, everyone came to know what is the power of artificial intelligence. Because everyone, maybe layman user also started using the different GPTs like ChatGPT, Gemini, this, that, and all. They were able to generate the content. Maybe it may be a text, it may be image, it may be a code, or it may be video, or it may be anything. They give some input. Based on that particular input, they were able to generate different kind of outputs over there. So it was a very easy step because there was nothing like coding and anything. Only thing is we need to give some prompts. Based on that particular prompt, it will generate the content. Till the previous era, till deep learning, everything was the programming. We need to write some code, then only we will be able to do some tasks. When generative AI came into picture, only thing what we need to do is we need to understand how to give the prompts. That was the only thing the people have to know. So that was the generative AI. And later we come across the agentic AI. From 2024 onwards, we came across something known as agentic artificial intelligence. So what is the difference between agentic AI and generative AI is in the generative AI, we have to give the prompts, and then based on the prompt, it will give you the result. That will it will generate some content. As said earlier, it may be text, image, code, video, whatever it may be. But what agentic AI is all about is it's a goal driven. We need to define what is the goal. What agentic AI will do is it will autonomously, you can say, plan to achieve that particular goal, and then it will accept the feedbacks and it will iterate over and over so that it can achieve that particular goal. We will discuss in detail about agentic AI later, but this is what the main idea behind that agentic AI, where we don't give prompts for everything. We define a goal. Based on that particular goal, it will do the task and all. And now, what we do is we will differentiate between generative AI and agentic AI because we are not much interested in the previous three rule-based machine learning and deep learning. We have to differentiate between generative AI and agentic AI. Generative AI generate the text, image, code, as said earlier. They respond to the prompts. We need to give some prompts. Based on that particular prompt, it will generate these content. They are stateless interactions. They don't remember anything. Whatever the prompt you give, based on that particular thing, it will give you the result. One shot output. Again, they don't. check whether that particular output is correct or wrong. We have to give the prompt, you will get the output. That's it. They don't cross check whether it is correct or not by themselves. Limited reasoning was there with respect to generative AI kind of things. The next thing what was came is, as said earlier, the agentic AI. They achieve goals autonomously. Here we need to define goals. Agentic AI will achieve that particular goal autonomously without the intervention of human. They do that particular task step by step. That is, they plan and then they will execute each of that particular task so one by one. Uses tools and external APIs. Tools and external APIs means, let's imagine we want to get the gold price in Bangalore today or maybe yesterday. So we cannot get it from generative AI. What we need to do is we need to use the APIs and then we need to get the current data. So that can be done with the help of APIs and different tools. They will generate the content. They will not give that in one shot. What they do is they will refine that output. They will cross check whether it is correct or wrong. If everything is fine, then only that will be given as an output to the user. So that's the iterative refinement. And there was a advanced reasoning was there in the agentic AI kind of systems. The next what we do is we will try to define the agentic AI. So this is the simple definition of agentic AI. Agentic AI refers to an AI system that autonomously plan, decide, act, and improve to achieve the defined goals. So, what we need to do, as said earlier, we need to define some goals. So, based on that particular goal, agentic AI will plan to achieve that particular goal, and then it will decide which particular steps to be executed or the action to be executed. Then it will act on those particular action. Can say that the steps you will get some result. That result will be improved iteratively. Once everything is confirmed, that will be given as an output to the user. So that is about agentic AI. Now, a very important question comes in front of us is, we have different eras of artificial intelligence. We have generative AI. Why do we need agentic AI? So question comes in front of us. Nowadays, whatever the problem we see in real world, they are not simple. They are complex problems that cannot be solved with the simple. We can say that the one prompt or like that. So we need to solve those particular problems step by step. We need to do iterations so that we will get the better results. So that's the reason uh, agentic AIs are required. We want the things to be done without the human intervention. So that is the another requirement. So autonomous systems are required in the industries where we don't want the human to intervene. Agents should do without the intervention. Whenever we are trying to solve dynamic or multi-step problems, simple prompts will not solve that. There is a limitation on the prompt. Whatever the prompt will give to the generative AI is that cannot solve the dynamic or multi-step workflows. Whatever the agentic AI or the AI assistants we are talking, they are not the chatbots. So we have seen a lot of chatbots. What they do is they respond to very few queries. We cannot ask anything and everything over there. But when it comes to AI assistants, they are autonomously working and they will do a lot of things other than what chatbots does. And the very important thing is enterprise maturity. Organizations are ready to move from experimentation to production. So they want to use the generative AI in such a way that each and every task should be done without the human intervention. So that is what they wanted to do. So we'll take some examples to understand how generative AI is different from agentic AI and all. If you consider this example here, generative AI is a calculator. I have considered a chartered accountant as the agentic AI here. Now, what calculator can do? It can give a correct answer when we enter the numbers. No, it doesn't understand the goals. It doesn't understand the context. It doesn't understand the next step to be done. Whenever we give some numbers, for example, 2 plus 3, it will give you the answer as 5. But it does not understand what was the goal, what was the context, and what was the next steps to be done and all. So that is what the generative AI is all about. So you give some prompts, it will give you the result. That's it. It doesn't understand what was the goal, what was the context, what was the next step to be solved, and all those things. But when you talk about the chartered accountant, he understands the financial goals, decides what calculations are to be needed, and check compliances, reviews the results, and based on those particular results, he will revise their strategy. So that is what the chartered accountant will do. So we can consider chartered accountant as a agentic AI and calculator as a generative AI in this case. Take another example. An intern as a generative AI, a project manager as the agentic AI. So what intern does? Intern completes the assigned task, needs continuous instructions. He has a limited autonomy. But when you talk about the project manager breaks the goals into different tasks, assign priorities for each and every task, and he will monitor the progress. And based on that progress, he will do some corrections. And the same thing will be repeated until these goals were achieved. So we'll take a few more examples. Let's say that a GPS map is a generative AI, a travel planner is an agentic AI. So with the help of GPS map, we can get the directions from our destination to source to destination, you can say, but it does not plan the trip, cannot handle the changing objectives. So that cannot be done with the help of, or that cannot be done by the GPS map. But what travel planner can do, he can plan the entire, can say that the trip. He will adjust the routes based on the delays, or maybe different kind of delays may occur. He will book the tickets, he will rebook based on changing objectives, and then he will optimize continuously. So this is what we can say AI travel planner. A travel planner is an agentic AI. A GPS map is a generative AI. Lastly, we'll take one more example. Question paper setter is a generative AI. An examiner is an agentic AI. So what question paper setter will do? It will generate the content one time. That's a one-time output. No evaluation loop was there. But when you talk about the examiner, what examiner do is he evaluates the responses, provides the feedback on the top of that particular responses. He adjusts the difficulty and assessment strategies. So he will be called as an agentic AI because he's working on a certain goal. He's dividing that particular task into different steps, and then he's solving those particular steps to get the final result here. So these are the some of the examples why agentic AI is required in current era. So coming back to the next thing, uh, is why what are the different design patterns are there to implement, or you can say design agentic AI systems. There are mainly five design patterns are followed. The first one is a reflection pattern, tool use pattern, react, that is called as a reason and act pattern, planning pattern, and multi-agent pattern. What we do is we will discuss each of these pattern one by one. We'll start with the reflection pattern. Now the question is, what is the reflection pattern? Reflection pattern allows an LLM. LLM is a large language model to evaluate and improve its own output before responding to the user. So what happens in reflection pattern is we give some query to the LLM. LLM will generate some content that will not be given as an output to the user directly. That will be evaluated. On the top of that evaluation, if everything is fine, it will be given to the user. Otherwise, it will be improved and then it will be responded to the user. So that is what is called as a reflection pattern. So instead of generating once and responding, what we do? Generate, evaluate, improve, iterate over that particular output, and then respond. So that is what we do in the reflection pattern. So you can see this diagram. The user will give some query here. That query will be given as an input to the LLM. It will generate the output directly. That output will not be given as a response immediately. What will happen? That will first go to, that will be considered as the initial output. That will go to the second one. That's a reflect LLM. What it does is it will analyze that particular output. If that output has some errors or discrepancies, what it does, it will iterate over that output, and then it will try to improve it. Once it will satisfied with the output, that reflected output will be given as an input to the LLM, and LLM will respond to the user. So this is the entire process of reflection pattern. Now, why reflection pattern is required is generative AI is fast, but it is shallow. It may not give you the proper output. It may search only certain number of you can say that documents and give you the result. Inconsistent output. You can ask the same question again and again. You may not get the same result. You will get inconsistent result to the from the LLM. LLM is overconfident. We can say that is it will give the result as if the result is correct. But many a times you just give the same question again and again, it will give you the different results. But every time it says that it is correct. So that is the one problem with respect to generative AI. But what reflection adds, whenever it generates some content, it will be evaluated, and then the quality of that output will be checked. If everything is fine, then only it will be given as an input to the output to the user here. So that is the advantage of adding the reflection pattern here. So rather than generating once and giving the result, we will evaluate the output. That output will be checked for the quality. If everything is fine, then only it will be given as an given to the user here. So this mimics the human expert thinking. The human also does the same thing. Whenever we ask them question, immediately they will not respond. What they do is they will think upon that question. They will generate the answers in his mind. He will check whether that is correct or wrong. He will evaluate himself. If everything is fine, if he found everything is fine, then only it will be he will answer that question. So definitely, the reflection pattern is a kind of human expert thinking in this case. Coming back to the we will take an example. Let's say that explain CNN to the first year students. So that was the task. So what was the draft answer is initially whatever the answer we may get is a too technical. That may not be suitable for the first year students. So what the reflection step will do? It will understand this is for the first year students because the students are beginners. It will add some analogy as well as it will remove the heavy math out of that particular uh, initial output, and once everything is fine, that will be given as an output with the visual representations. So that is the reflection pattern. The second one is something known as the tool use pattern. So this is the another pattern with which we can design our agentic AIs. What this tool use pattern is, tool use pattern enables LLM to call external tools, APIs, and databases instead of relying only on the internal knowledge. So how LLM works, everyone knows. The LLMs were trained on a huge amount of data. Based on that particular trained knowledge, they will give you the output. So that is how actually the LLM works. But what this tool use pattern does is, along with that internal knowledge, they call the external tools. They call the APIs. They use the databases to give the better results. I'll take a simple example. Let's say that I think I have given the example earlier also. We have asked the question like, what is the gold price in Bangalore today? So that cannot be given from the internal knowledge. Internal knowledge is the knowledge what it has acquired from the training. This particular trained knowledge does not have that current data. Current information is not available. So what tool use pattern does is these LLMs call these external tools, APIs, and databases. They will get the current data, and that current data will be given as an input given to the user here. So that is what the meaning of tool use pattern in this case. So this is how the tool use pattern looks like. So again, the user will put a query that will first go to the LLM. Of course, LLM is required whenever we talk about agentic AI. The core part of agentic AI is LLM only. So there is no doubt about it. But how we use LLM, that is the important thing over here. So query will go to LLM. LLM, what it does, LLM will call some tools. If required, it will not call the tools all the time. If required, they will call the tools. As said earlier, they may not be having the real world, real time data. So if it requires real time data, they will call the tools, maybe databases or APIs or whatever it may be. And then based on that, they will generate the content. that content will be given back to the user here. So that is how the tool use pattern looks like. So again, I will take one more example. Let's say that we want to know what is the weather conditions in Bangalore right now. So if you want to know that particular thing, again, LLM does not have that information. They have to call some APIs. They have to get the output out of that, and then they have to generate the result, and that will be given to the user here. So why we need the tool use pattern is whenever we want the fresh data, the precision data, and grounded answers. In such cases, we can use the tool use pattern here. Again, the same example I have in this particular slide. What's the today's gold price in Bangalore? So it will call the live APIs to get the live price, and then the current data will be retrieved. Based on that particular thing, they will respond over here. When to use, again, as I said earlier, whenever we are talking about the financial data, the scientific calculations, real-time dashboards, or real-time data is required. In such cases, we can use the tool use pattern here. The next one is the React. The React is reason and act pattern. So what is this pattern is? So there are two things are there. Reason, that is a reasoning. It will think about that particular query. They will do some actions. Once the action is done on the environment, they will observe the result. If the results are satisfactory, the result response will be given. If the results are not satisfactory, that will be adjusted. Again, the adjusted reasoning or thinking will be executed on the environment. Again, the results will be observed. The same thing will be repeated again and again until we will get the perfect results. Once the perfect result is obtained, that will be given to the user. So I hope you can see that React pattern here. So this one is the query. It will first go to where? It will go to LLM. It will do some reasoning. It will do some thinking on the top of that. It will get the result. So if required, it will use the tools also to get the result, because sometimes we need tools also. So once we get that particular result, that will be executed on these actions will be executed on the environment. Now, once the actions are executed on the environment, the result may be satisfactory or may not be satisfactory. If it is satisfactory, it will generate the result and that will be given as a response. If not, what it does, it will do this reasoning again using the tools and different things. Again, it will be executed on the environment. The same thing will be repeated again and again over here. Once everything is satisfied, then the response will be given to the user here. So this is called as React pattern in this case. So why it matters is because AI becomes agent like. We don't want the agent to be chatbot. They should act like an agent. They should act like a human or something like that. So that's the reason we need this React. Whenever we want to solve multi-step problems, we want decision making, adaptation. In such cases, we can use these React patterns here. So let's take an example of to understand the React pattern. Let's say that we want to fix the server downtime. So what we do first? Or what AI agent will do. First, it will check the log files. So once it check the log files, it will do one query. That is a action. It will do some action. What is that? Query monitoring tools. It has observed that disk is full. Because disk is full, it will execute one more action, that is clean temporary files. And then it will verify whether the server is up and running. If everything is fine, it will be reported to the user. So what it is doing is it has done some reasoning. It will act that particular thing on the environment. It will observe the result, and then this again it will do some different action, and then it will verify the result, and finally it will give the result to the user here. So that's how actually the React pattern works in this case. The next one is something known as a planning pattern. So planning pattern decomposes high-level goals into ordered subtasks, executes them, and check the completion. So that is what is called as the planning pattern here. For example, if you want to arrange this FDP, which cannot be done by the single person or something like that. A group of people must be present behind this one. One person must have applied for the sponsorship. Another person must have discussed with different resource persons. Third person may have the responsibility of taking the registration. Fourth person may be having the responsibility of arranging these online sessions and so on. So each and this particular task cannot be done by the single person. So what we need to do is we need to divide that thing into different subtasks, and then we need to execute them in a proper order so that we can get the end goal here. So to do this particular thing, we need whenever we want to solve such kind of problems, we need something known as planning pattern here. So this is how actually it looks like. The query will be given to the planner. The planner will generate the different tasks, and each of those tasks will be executed in a particular order. And then once all of them were executed, we will get the result, and that result will be given back to the user here. So this is how the planning pattern will look like. So I will take one simple example to understand this planning pattern. Prepare 1 hour session on fundamentals of CNN. So this may be the goal to be achieved. So what we need to do here is, or what planning pattern will do is, it will generate the objectives first or defines the objectives. It will create the slides. Second task. Third task may be design the demos. Fourth may be adding some assessments. And finally, review the content. So these may be the different tasks, and each of these things should be executed in a proper order. We cannot directly review the content, or we cannot directly design the demos or so on. So we need to start from objectives, and then we have to go in this particular order so that we can solve this goal here. The last design pattern is a multi-agent pattern. Multi-agent pattern uses the multiple specialized agent that collaborate, delegate, and coordinate like a team. So this is what actually the agentic AI is all about. Whatever we have discussed in the previous slides, up to that was AI agent. AI agent is there is one agent who is doing all the tasks. When we have multiple number of agents, then it will be called as what? Agentic AI. So here what happens is there will be different agents are there, and each of them are doing different tasks so that we can achieve the final goal here. So why do we need this one is a single agent don't scale, or we can say we cannot do everything, or we cannot assign everything to a single user. The same example, like arranging this FDP cannot be assigned to a single person. It has to be the task should be divided to multiple number of uh, groups, and then it has to be solved here. Because each person may be having different specialization. Parallelism can be done, and robustness can be achieved with the help of multi-agent systems. And this will mirrors the real organization. In organizations, everything will not be done by the single person. When we develop a particular software, it will be done in a teams. It will be done in different teams. That's the reason multi-agent patterns reflects the real organizations here. So this is how the things will look like. User will give the query. It will go to the project management agent, and this particular project management agent will send this to tech lead agent, and then software development engineer agent, and then there will be something called as a DevOps agent. Each of these particular people are doing the task in we can say that coordination to solve a particular problem. And once everything is done, that response will be given back to the user here. So this is a multi agent agentic AI here. So we will take a simple example before we proceed. Let's say that we want to write a research paper. So we can have some different agents. Each of the agents will be doing different tasks. The first agent may be doing the literature review. Second agent may be doing the methodology, drafting or writing the methodology. Third one may be doing the result analysis, and fourth one is the proofreading and so on. So each of these things should be done in a proper order, and there should be coordination between each of those things. And with help of that, we will be able to achieve the final goal here. Now, we have discussed what is the agentic AI, why agentic AI is required, and what are the design patterns to design agentic AIs. Now, we will discuss the agent architecture and design before we proceed with the demonstrations. Agent architecture and design. When we talk about this one, there are mainly 6 modules are there in agentic AI. The first one is a goal module, second one is planner, third one is tool integration, fourth one is a reasoning module, fifth one is a memory system module, and last one is feedback loop. I will discuss each of these modules one by one briefly. Uh, the first one is the goal module. The goal module defines what success means, because without each of these things, we will not be able to design any agentic AI system. So each of these things are compulsory. The first one is a module. Goal module defines what success means. It answers what is the objective to be solved, what are the constraints to be considered while achieving this particular goal, when should the agent stop thinking or doing the task, because these are the very important thing. Without having this particular goal module, we cannot achieve or cannot design agentic AI here. So these are the functionalities. Let's say that first we need to define the success criteria. So again, it will be a task of a goal module. Success criteria has to be defined. It has to set the constraints. It has to track the progress. So when we talk about success criteria, the example may be something like this. Student understands CNN basics. That may be the goal or the success criteria, I can say. To make sure that this goal is achieved, we need to set some constraints, like what is the time limit, what is the budgetary limits are there, what are the ethical constraints to be considered, what about the data privacy constraints are there. Everything has to be defined in the goal module. So the next one is the track progress. Are we closer to the goal? So that is the first thing we have to do. Again, it has been done in the goal module only. Are we stuck in between? Or do we need to do the replanning or something like that? So all these things will be done in goal module. If you don't have a goal module, what will happen? Agents keeps on generating endlessly because we don't have the stopping condition. We don't have any goal. In such condition, what will happen is the agent will go on generating endlessly. It may go into infinite loops, or we may not get the result also. So that may be the problem here. The second one is something known as the planner module. The planner module converts the high level goals into structured tasks. So we have defined the goal in the previous module. We have to convert those particular high level goals into different tasks. So that is the main task of planner module. So what it does, it will break the goals into smaller tasks. For example, if you are designing a agentic AI for publishing a research paper, the task may be literature review, methods, experiments, and writing. So this is the first task of planner module. Second one is it will draw something known as the dependency graphs. Because when we divide this goal into small tasks, each of these tasks may be independent or they may depend on one another. So in such cases, we need to understand which particular tasks are independent, which of them are dependent on one another. For that reason, the dependency graphs are compulsory here. Uh, you cannot write the results before the experiments. So that's the meaning of this one is the results task depends on the experiments. That is how actually we can understand it. The third thing what planner model does is the resource allocation. So what it does is what are the tools to be used, how much compute power is required, which agents to be used. All these things will be done in the planner module only. Now, if you don't have a planner model, what will happen? That's the very important question we need to answer. If you don't have a planner model, agent jumps randomly from one task to another task or doing that same task repeatedly, cannot handle the complex tasks. And all these things can happen if you don't have the planner model. Coming back to the next module, there's something known as a tool integration module. Uh, allows the agent to interact with the real world. As discussed in the earlier slides, whenever LLM needs some real world data, it is doing some financial computations or something like that, it needs a real world interactions. So we need some tools to interact with the real world. LLM cannot browse the internet. That they cannot browse. They can give the reason only based on the knowledge what they have acquired when they were trained. They cannot browse the internet. They cannot calculate reliably. They cannot execute the code. For example, if you want to execute this one code in LLM, what is required is if it is a Python code, we need an interpreter. If it is a C code, we need a compiler. So what is required is we need some other thing than the LLMs. So LLM cannot do all these things. So tool fixes all these things. So we can integrate the tools in our agentic AI to do these tasks here. So what are the different tasks of tool integration is searching the internet, doing calling some calculate functions, running some code or something like that. That can be done with the help of APIs as well as the databases. The third very important task is the error handling. So whenever API has written something, it has to be cross-checked whether it is correct or wrong. Maybe API failure may be there, or timeout may have happened, or invalid responses are there, or something like that. So all these things has to be checked properly in this case. So let's say that we don't have a tool integration model in agentic AI. What will happen? So whatever the LLM has given, they may be the hallucinated facts. They may not be correct one. For example, if you are asked what is the weather condition in so and so area, because they don't have any information and they don't have any APIs and all, they will give some random output, and we assume that that's a correct one. So that thing should not happen. Real-time data cannot be given real world impact. No real world impact would happen without tool integration. Coming back to the next one, there is something called as reasoning model. This is the core of any agentic AI system. Of course, this without this we cannot do anything. If if we don't have planner model, if we don't have other models, of course we can do some agentic AI. We can implement agentic AI systems, but without reasoning model, it is not possible. This is the intelligence core of an agent. Here, what actually happens is they will decide what to do next, which particular tool to be used, how to interpret the results. All these things will be done by the reasoning model only. The reasoning model's backbone is the GPTs, Geminis, Groks, and so on. These are the different LLMs. Uh, they will do the task step by step. They help in multi-step decision making. They do the decisions with the different reasonings like if then style, policy based, heuristic rules, and so on. All these things will be used to make the results the user. If it is not available, of course, the agent will become the rule based. The core artificial intelligence, what has arrived in 1960s or 1970s or something like that. It works on the rule based. It doesn't think. It does not adapt. There is no intelligence. Nothing was there in that case. The same thing will happen over here also. The next every class will become the first day class for that particular student. The same thing will happen in agent also. If it doesn't remembers what happens in the previous prompt, what happens in the previous interaction, what happens in the previous to previous interaction, the everything will look like the new the thing only for the you can say that the agentic AI. So what is required in this case is there is a need of a memory module. Without memory module, as said, everything will looks like the first day itself. How the memory will be used is the memory can be of vector based, it may be context based or history tagging. Anything may be there. This is how the memory model will look like. If it doesn't exist, there is no personalization. The mistakes may be repeated again and again. Stateless behavior. So these are the things will happen without memory in this case. Coming back to the last component of agent architecture and design is the feedback module or the feedback loop, you can say. Feedback loop enables the self correction and improvement. So this is another core important part of agentic AI. Whenever we get a result, they have to be self corrected. If it is having some correction is required, they will be improved, and then the improved result will be again self corrected. The same thing will be repeated again and again. Here we can take the feedback from the end user also. Finally, we can give that particular result to the user. So this makes the agentic AI they are not the reactive. They are they make the proper decisions over here. This can be done with the help of these things: observation, passing, result validation, and error corrections. We can use all these particular things in a feedback model here. I will not go on each and every point, because what my part is to give the concepts about the agentic AI. And a very important thing, what I wanted to do is I wanted to do some demonstrations. So that's the reason. I think whatever the discussions we have done till now, it is enough with respect to the concepts. So we have started, as said earlier, we have started with the AI evolution, and then we have discussed what is agentic AI, and what were the differences between generative AI and agentic AI. We have discussed what are the different design patterns are there, and what is the architecture of agentic AI. We have done this discussion. I think these concepts are enough for agentic AI. Now, what we try to do from here onwards is we will try to do some demonstrations, like how agentic AI looks like, how to design agentic AI. Again, we are not going to consider each and every component of agentic AI. I think I have discussed about goal, memory, tool, this, that, and all. We may not be using each and every component, but what I will be doing is I will try to build a very simple agentic AI systems, so that you can, if it is required for you people to build such kind of things, you can build by yourself also, and we will understand actually how each of these things will be built uh, in the real world or something like that. Rather than just going through the theory, I think this will be the better option. Before I proceed, Mahesh sir, whether everything is fine, or anything is
Yes, sir.
required from.
Yes, sir. Everything is fine now.
Yes,
Everything
sir.
is
So
fine.
in that case, I will go ahead with a few of the demonstrations, or how can we implement agentic AI systems, sir, from now onwards.
Sure, sir. Sure, sir. Sure.
Okay. Okay. When we talk about the implementation of agentic AIs, there will be three levels in which they will be designed. It will be started with a beginner level, what people are or what we are using right now, like ChatGPT, Gemini, or whatever it may be, where we don't do any coding. We do with the help of prompts. We give some prompts, we will get some results out of it. So that is how the beginner level of agentic AI systems. Again, you can consider them as a agentic AI, because the main core part is LLM. LLM is present. You are giving some prompts, you are getting the results. Of course, you can consider them as agents also, but they are not a perfect agents here. The second level is the intermediate level, where we use low code frameworks. We can say that we use N8N, LangChain, Semantic Kernel, or Bubble IO. With the help of these, what we do is we will build our agentic AIs. These are the low code framework, means we have a drag and drop kind of systems are there. If you want something to be required in your agentic AI, you can search it and then you can use it. That's it. There is no need to write any codes or something like that. Of course, a bit of knowledge is required because we are going to send a variable from one node to another node or something like that. So that's the reason. Definitely, some coding knowledge is required, but we are not going to write everything from scratch. Only if the variables will move from one end to other end or something like that. So I will show you this in our demonstration. I will be using the N8N to build the agentic AI systems. Of course, you can use LangChain, Semantic Kernel, or Bubble IO. All of them works on the same basis. The last one is the advanced level. This is what actually the people use in the industry or something like that. Full code implementation. Again, it is not that the people are not using N8N in the industry. Of course, they use it. If it's a very specific task or very high level or a complex task, the people usually use the full code implementation. But in some industry, they use these things also, like N8N, LangChain, Semantic Kernel, and all those things will be used in the industry also. So in this full code implementation, there is nothing called as a drag and drop, or so such kind of things are there. Maximum things to be written in some programming language. Usually, the Python is the preferred language over here. With the help of this, we will be able to create agentic AIs. Now, what is the main difference between intermediate and advanced is intermediate first difference is the low code and the full code. That's the first one. Because it's a low code, we don't have much control on that particular nodes and all. Because what is already implemented, we are going to use in our system. Because it's a full code implementation, we have full control on the top of each and every node. We can write our custom logic. It's a production grade. You can say that implementation. You can say, but definitely the people are using low code frameworks in the industry. The people use the full code implementation also. So in this demonstration, as I said earlier, I'll be using the low code framework that is NA10. This is the very easy way of implementing agentic AIs over here. Now, for our demonstration, whatever I'm doing in this demonstration, we need some softwares as well as the tools. I'll be using N18 as said earlier. I'm using the cloud version. You can install this N18 in your desktop or you can install through Docker also. Everything is perfectly fine. Once you install it in your desktop or Docker version or cloud version, everything is exactly same. There is no question. Whatever is suitable for you, you people can use it. I'm using the cloud version in my demonstrations. Now the question is how this NA10 works. I have some slides or you can say that screenshots. You can just check it out how to use NA10. If you want to use NA10, of course, we have to search NA10. You will get the first website, which is NA10.io, or directly you can type it in the uh, address bar so that you will be able to get the homepage directly www.na10.io. Once you open this NA10.io, this is how the homepage will look like. It is not the free, can say that the software or can say that the framework. It is a paid software or the framework. You will get the 14 days free trial, complete trial. It is not only certain features are available or something like that. Entire features are available for 14 days. You can try it out. If you are happy with this one, you can use it for building some agentic AI applications with the help of the paid version. That is left to you. Whenever we want to use this NA10, again, we need to click on this get started for free, or you can click on this one, get started. So once you click on this one, it will ask you some of the information like whether you have already have an account or you want to create a new account or something like that. When we want to create a new account, we need to fill all these fields like name, email ID, and all. It is saying like we need to enter the company email. There is no such necessary here. You can use your normal Gmail account or Yahoo account or whatever the personal email IDs are there. You can use them. You can give the name of your account in this case. So this is again, as I said earlier, I'm using a cloud version, so that's the reason all these things are required. If it is a local version, again, we need to create an account. There is no question about it. But in that case, we don't get this one, cloud URL. We will get the different, the local host URL in that particular case. So you need to fill all this information. And then you need to click on start 14-day trial here. Again, I said it's a 14-day free trial, but it is complete, what you can say, complete features are given to you for 14 days. You can use them over here. That's the first thing, and it will ask a few more questions. What is your background or something like that? You can select whatever it may be. From here, you have heard about NIT and all. Once you click on submit button, it will ask you to invite the team members to your workplace. Again, if you're working alone, you can click on skip here. But when we talk about industry or something like that, the group of people are working to solve a particular goal. So in that case, we need to add each and every person to this work space. So we need to enter their email IDs and then we need to add or invite them. Once he has accepted, everyone will collaborate to solve a particular goal in that case. So that is how we can create an account in N8N. So once we skip it or when we invite and then we submit, click on submit button, we will get this particular page where our workspace is now online. Okay. And then we need to start building agentic AIs by clicking on this button. There's something called as start automating. Once you click on this particular button, this is how the user interface will look like. As I said earlier, this interface is the same in cloud version or desktop version. Everywhere it is same. There is no change. You can see here it's a 14 days left. Uh, Yesterday I have done it, so that's the reason it is showing yesterday. If I open it today, I think it will be 13 days or something like that. So in a day, you can do 1,000 executions. You cannot do more than 1,000 executions uh, over here. Means you can call the APIs, or can say that you can execute your work space or workflow 1,000 times in a day. That is the maximum thing you can do. And here you can see some of the buttons like to search, create new workflow, and so on. This is a try and AI workflow. If you click on this one, already some examples are there. You can play with those examples. If you click on this particular thing, you will be able to create from scratch. So that is what will happen. So again, I'll tell you, it is not that we can use only NA10. In a low code framework, there are other things are there, LangChain and all those things. Everything looks almost same. This is quite simple compared to them. That's the reason I have taken this one for demonstration purpose. So once you click on this start from scratch, you will be able to build your workflow. Here you can give the name of your workflow. You can start adding different nodes. Like you can add, you can say that your Google form. You can add your webhook. You can add your Gmail. Whatever you wanted to add into that particular agentic AI, you can add all those things over here. Now, once we will come back to this thing at the later stage. We will talk about other requirements. This is the first requirement, as I said earlier, NA10. The other requirements are like we need some LLM provider. Uh, we can use Grok, OpenAI, or Gemini, or any other LLM provider. I think I have already said LLM is the core component of this agentic AI. So you can use anything here. I'm using Grok. The reason is very simple. Whenever we want to use Grok, OpenAI, or Gemini, we cannot use our normal account. What we need is we need a enterprise or can say development kind of account, and we need to get the API keys. With the help of API keys, we can use all these LLMs in our agentic AI. OpenAI and Gemini does gives free API keys, but they have a very limited, we can say that the tokens. Grok gives better number of tokens, so that's the reason I prefer Grok in this demonstration. So I will tell you how to create API keys and all at the later stage. In this demonstration, we need a Google account, we need a Google Forms, Google Sheets are required, and any email account is required so that we can send some email and all. That's what I wanted to show you here. So that's the reason some email account is required. Maybe Gmail or any other account is perfectly fine. There is no question about it. So these are the different softwares and tools. So what I'm going to use in this demonstration. So what I'm going to build in this case is I'm going to build two things. One is a single agent system and another one is the multi-agent decision system. In single agent system, I will be showing you how can we build assignment evaluator. So the main idea in this particular case is we will accept the assignment from the Google. We will store those particular assignments into a Google Sheets. Whenever a student has submitted an assignment, immediately that will be given as an input to the agentic AI system. It will evaluate it based on a certain prompt that we have to design, and automatically it will give the result, like how many marks he has got or something like that. And finally, that result will be sent through email to the user as well as to the teacher. So this is the entire workflow over here. We will divide it into small subtasks and then we will try to understand how to build it. But that is the main idea. If time permits, I will take one more the agentic AI system, that is a multi-agent system, where we will discuss about how can we add multiple number of agents to solve a certain task. For example, we want to solve something like this: which fruit should I eat today? So in this case, there will be based on the options and certain we can say priorities, or we can say that some constraints. Uh, it has to give you the answer, like what particular fruit should I eat today. So here we will do the two agent system. The first agent will analyze, and then second one will be making the decision. Again, if time permits, I will go ahead with this one. Otherwise, we will discuss this assignment evaluator in detail here. So you may get one question like we have Google Forms. We can generate the quizzes and all. Of course, we can do, and we will get the results immediately. I'm not talking about the quizzes and all. I'm talking about the theoretical answers. How can we evaluate the theoretical answers automatically or something like that? Autonomous assignment evaluator system. So that is what I'm talking about here. Now, this is how the workflow will look like. We need this is the I will be dividing this into three demonstrations. The first one will be webhook based evaluation, where we will accept the input through webhook. We will build the prompt. We will give that as an input to the LLM. LLM will give the result here. So this is the entire workflow here. So this is not autonomous. It is the manually triggered. We need to give the input through webhook, and then it will give you the response. It does not have any autonomous thing in this case. So at the autonomous T, what I'm doing is I will be giving another demonstration where I will accept the assignments through Google Form. I will store them into sheets. Whenever a new assignment has been added to this sheet, like new student has submitted the Google Form, what will happen? Automatically, a trigger will be executed, and then the new assignment will be given as an input to the LLM, and we will get the output here. Now, finally, what I'm going to do is the same thing till here. Only thing is the result will be emailed to the student as well as to the teacher. So that is the last thing what I wanted to do over here. So this is what is the main demonstration I wanted to do. So what I will do here is I will start from scratch. Uh, so what is the thing I have to do? I think I have already said. We need to start with N8N. As First we need to search N8N or N8N IO directly. We can open. Get started. We click on the get started. If it is the first time, we need to give all this information. Because I have already created an account, I will directly click on this particular login. And then my login account name I will enter here, and then I will click on sign in here. Because again, I think I have shown all the steps to create an account and all. I can follow those particular steps also. Now you can see here, I have done some can say that the executions, 23 production executions I have executed. Out of that, six were failed. Failure rate is given here. Run time for each and every execution is listed here, and so on. All these things are present here. All these things are already present, but I'm not going to show you the things directly. I will start building from the scratch. So what I will do is I will click on this particular plus, and then workflow, and then I will click on personal. So what it does is it will give you the editor where we can start building your own, we can say that agentic AI system. So here you can rename it. So I will name it as assignment eval, that is assignment evaluator. So that is the name of that agentic AI system. As shown in the previous slides, that's the first one. I will be doing this one, that is webhook. From webhook, I'm going to accept the input here. Okay, so what I will do in this case is I need to add some webhooks. I need to add some sample input so that we can do the processing and all. So for all these things, I have designed, we can say that some steps to be followed. All those things are written in this thing. I will share this with the organizers. If you want, you can take this thing. So what is the thing? We need to start with the webhook. We need to set the variables here, and then the LNM, and then the response. So this is the entire workflow. So this is what we need to create here. So how can we do that one is we need to create a webhook node. You can see here, create a webhook node. How to do that one? Click on plus, it will open here. So just we need to search for webhook. So once you click on this particular webhook, there will be some different things are there. You can see here, there is something known as the get method is used here. In this case, we are going to post, we are using post method because we are going to give some input to the LLM system. So that's the reason we are going to use post here. The path, you can change it according to your requirement. I will write ASS EFAL, assignment evaluator. You can see here, this particular URL has been changed. You can use this URL so that
Sir,
we can.
excuse me, sir. So please
Yes, sir.
repeat the previous step once after changing the name of workflow.
Yes, sir. One more time I will go. Once we change the workflow name, the next thing is to add different nodes. What are the different nodes are required to solve that particular, can say that any goal or anything we want to do. In our case, I will be showing this particular workflow. So what this particular workflow does is, here first we need to add one webhook node through which we will be accepting the input. Second one is we need to set the variables. This is the compulsory thing because that variables will be, in this case, we'll store the input. That is the thing. The stored input will be given as an input to the LLM system. LLM will do the reasoning on the top of it. And then finally, it will give you the result here. To do this one, first we need to add this webhook module, or you can say that the node. So first we need to click on this plus, or directly you can click on this plus also, or you can click on this search. Anything is perfectly fine. So when I click on this one, here we need to search webhook. And when I click on this one, it will give you this particular prompt. Because we are going to give input to this webhook, here we have different methods are there. In this case, we need a post method. You can give any name here, or if you don't change, it's perfectly fine because it is automatically generated. It's a very difficult to remember. So I will do one thing. I will give any name here. I will give ASS eval or something like that. That is what is added in this. You can see here. This is the path. Authentication right now, I'm not going to use anything. You can use different authentication methods are there. For simple demonstration, I'm not using this one. The next what is required is when to respond. If I say immediately, it will give you the whatever the input is there, the same thing will be given as an output. That is not required for us. What is required is we want to get the output when entire workflow is executed. So that's the reason we need to select when last node finishes. We want the result here. So that's the reason when to respond when last node finishes. What is the kind of response we are expecting? In what mode? Different things are there, all entries, JSON format, first entry and all. So for time being, I will select JSON. That is a JavaScript object notation where we have, we can say that keywords and the values will be present here. Now, this is the response data. Here you can see here. Here we are giving the input. So input will be in this particular format. It will be what is the key and what is the uh, answer or can say the value for that one. So here you can see I have some random input. You can see this one. So what is this input? I will explain later. So I will copy and paste it in this edit output. So once again, I will show you the webhook. Through webhook, we are giving the input. So we will set the mock data. So here, what I am doing, I am copying and pasting this particular input. So what is the input is? The question is explain CNN. What is the rubric to be followed to evaluate this question? Concept should be given 5 marks, clarity 3 marks, example 2 marks, and answer is also given. So this is, can say that ready-made information we are giving. It's a manual trigger. We are not doing any autonomous or thing in this case. So once you execute this one, you can see here the input and output you will be able to see. The meaning of this one is this webhook is working perfectly fine. If you click on this one, uh, you will be able to get that particular output immediately here. Now, what I will do is, in the workflow I have shown, the second one should be the set node. Set node, what it does? Set node will set those three things. What are they? Question, rubric, and answer. And they will be set into a proper prompt so that the LLM can accept the prompt and do the execution. So that is the very important step. Set is compulsory. So I will do one thing. I will select a set. Again, I will click on this plus, and then I will search for set here, edit fields. So this is what the thing I have to select. Here you can see there are different things are there. JSON mapping is there and manual mapping is there. I will select the manual mapping. You can see what is the input to this one. From webhook, we are getting question, rubric, answer. These three things should be set into a proper prompt here. So that is the reason what I will be doing is I will show you that thing over here. You can see here, create a node. We need to create one prompt here and the value for that particular prompt we need to design here. So what I will do, add a field. Here I will mention it as from, that is the variable name. Within this variable name, I want to store some value. So what the value should be? This value is what we give to the LLM. So what we will give to the LLM? Answer, give answer to this question or something like that we will give. Explain CNN, explain something else, write a code for something, some other things. So similarly, we have to design our prompt here. I have designed this particular prompt. I will read it out so that you can easily understand. You are an university assignment evaluation agent. This is what the first line I have written. The question is equivalent to JSON dot question. The meaning of this one is from the previous webhook, we are going to store that into our prompt. To get that particular thing, what I have written here is JSON dot question. The rubric is equivalent to JSON dot rubric. Again, we have set the rubric what should be followed in the webhook only. So that will be written in the second step. Answer is equivalent to JSON dot answer. The answer is present. You need to evaluate this particular answer. So this is the fourth part of our prompt. Next is how the response should be there. That is what I have written here. Respond only in this format. What is the format? Total marks, strengths, weaknesses, improvements, and Bloom's level. So you need to give this response. How the evaluation should be done? The maximum marks are 10. The rubric should be followed is this one. Out of 5, the concept should be evaluated. 3 for clarity, 2 to the example, and finally you have to give the results, obtained marks out of 10 here. So this is the prompt what I have designed. So I will need to give this prompt over here in the set node. So what is the variable I have taken? Prompt. In this area below, you can see here there are two things are there: fixed and expression. Select expression and then paste it here. So once I paste it, you can see the result also immediately, or execute it here. So once I press execute, you can see the prompt. Your university assignment evaluator question is what? Explain CNN. That is the, you can say that question. What is the rubric to be followed? 5 for concept, 3 for clarity, example 2. What is the answer? Answer is this one. How the response should be there, and all those things are present here. So from where it is coming? It is coming from the webhook, and it is stored into a set node here. So from webhook, we have given the input. All of them will be set into this set field here. Now the next thing what we need to do is whatever the prompt we have given or written, it has to be given as an input to the LLM here. So first what we do is we will click on this plus, and then I will search for basic LLM chain. So once I click on basic LLM chain, you will get this one, basic LLM chain. And then we need to click on this model. What is the model we are going to use here? So the model may be anything, as I said earlier. We can use OpenAI. You can see here chat model, or we can use Gemini, or we can use anything else. In our case, or in my case, I'm using Grok, as said earlier. It is giving more number of tokens. So that's the reason I'm using Grok here. Now, when I select Grok, there will be one thing comes in our case is how to connect to that particular Grok account. So again, I will show here. This is a Grok is created. It is connected over here. I hope you can see as a model. Now, if I double click on this one, you will get this particular window. Here we need to connect it to our drop account. So for that reason, you need to click on this drop down. I have already connected. That's the reason it is showing the Grok account. Otherwise, you need to click on this one, create new credentials. Once you click on this one, you will get one prompt where you need to paste your API keys. So that is the thing we need to do. Now the question is from where we will get the API keys. To get the API keys, I will show Grok. The same thing can be followed for OpenAI as well as to the Gemini also. So when you search for Grok, you can see here API keys. Once you click on this particular API keys, I have already logged in over here. So that's the reason this particular prompt is coming. What we can do is you can log into this particular Grok using your Gmail account, and then you can click on create APIs. So once you click on create APIs, you can give any name over here. I will give ATAL. When it will be expired, I will take it as a 7 days or whatever it may be. And then I will click on submit button. So once I click on submit button, it will generate the API keys over here. That API keys, what we can do is we can use in our uh, uh, agentic AI. So you can see here, this is the API is created. I will copy this one, and then I will go back to my uh, just give me a second. Here I will go back, and then I will create new credentials, and then I will paste it here. And then I will click on save. If everything is fine, you can see here connection tested successfully. So API key is up and running in this case. Now, next, what I need to do is I need to select one model. All Grok models are not available free of cost. So we need to select one free model that is 3.18B instant is a free version. We can use it. If you are using it a production grade, we need to use the paid version also. So this is the one thing we need to do. So again, I will explain this one. So double click on Grok chat model. You need to click on this Grok account, and then you need to select whatever account you have selected already, or else you need to create a new credentials, and then you need to paste API keys, and model should be this one. You can try with other models. It will say that this model is not supported. It is not free of cost or something like that. So Grok model is selected. Now, to this particular Grok chat model, we have to give this prompt as an input. So we have created already prompt. That prompt should be given as an input to Grok chat model. Now the question is how. So that can be done with this basic LLM chain. Double click on this one. So this is the prompt what we have designed, or this is coming from the set module. So here we have to set it. What is that? Define below. Define below. That is what we are going to define. And what is the code we have to use? That's the reason I said a bit of code is required. JSON dot prompt we have to use. So again, I will show you. We have to select define below. Here I have to select expression and then JSON prompt. You can see here, whatever is present in a set node, all these things are coming here. You are an university evaluation agent. Question is this one. Rubric is this one, and all these things are present here. And then I will close this one. So once I do this particular thing, what will happen is or we can add one more module also. That's a webhook response. That is not necessary here. Now you need to click on save button, and then you can click on publish. Now, if you want to check whether everything is working fine or not, what we can do is uh, we can click on this particular execute workflow. Now you can see here workflow is executed successfully. Click on the last module. You can see this one text. The total marks awarded for that answer is 5. What are the strengths are there? I think I am expecting the result in the form of strengths, weaknesses. That's the second one. The third one is improvements. And the next one is the Bloom's level. All those things in which it is analyzed, and we got the result over here. Again, you can say that this is not autonomous, but end of the day, what we did is we have designed some, what we can say that the agentic AI, where we have given some input, and then the LLM module was able to do what we can say that reasoning on the top of that, and then it has given the output over here. So this is the output what we got, and we got the 5 out of 10 as the marks also. Now, because it is not autonomous, it doesn't looks like an agentic AI. So what we try to do from now onwards is we'll try to make this one as you can say that autonomous. I think we have hardly 10 minutes left. I will go somewhat fast. So to make this one autonomous, what we'll try to do is we will replace this webhook with our Google form. Whenever users submit some, you can say that the form, automatically this particular model should execute, and automatically the result has to be stored into some sheet, as well as the email has to be sent. So what for that reason, what I will do is I will remove this particular webhook. That's the first thing I will do. And I will add one more module here. There's something called as Google Sheets. Google. I hope the requirement you understood. Like I want to make this one as you can say that autonomous. So when this particular LLM model should be executed, that's the question comes in front of us. So whenever a new row is added, whenever new row is added means whenever a new response has been added into that particular Google form, it has to be executed. Now you can see here, it will ask the Google Sheet trigger account. That's the first thing. we need to select again the Google Sheet from where we are going to get the input. For that reason, we need to create the credentials and all, then all those things. So before that, I will do one thing. I will create a Google form first of all, because from there we are going to accept the result, Google form. I will click on Google form here. I hope all of you know how to create a Google form, so I don't want to discuss here. So blank Google form. Here we can give ASSN eval. Here I will give the name as ASSN eval. And then what all things are required here? First thing, what is required is the name of that particular person is required. So it will be, you can say that small, short answer. It's a compulsory thing. Second thing, what is required? We take email. I will take email here. Again, it's a short answer. It's a compulsory field is required. Third one is the question. Question. So question is common here. So that's the reason multiple choice I will select. Explain CNN. It's again compulsory. Next one is rubric to be displayed to the user so that he will answer accordingly. So answer again, it is multiple choice only I will take. So concept, 5 marks. You can say that clarity or something like that was there. For that one, it is 2 marks. Sorry, 3 marks. And example, 2 marks, something like that. Again, it is compulsory. And the last field is very important. Answer. Yes, yeah, answer. This is a paragraph, and this is also compulsory. So this is the Google form what we have created: name, email, question, rubric, and then the answer here. So these are the 5 fields we have created. What we need to do is we need to create a responses link to click on this link to sheets and then create here. So once it is created, you can see here, you will get one sheet. There will be timestamp, name, email, question, rubric, and answer. That is what is created whenever we create a Google form here. Now, when we submit this particular Google form, what will happen? A new row will be added. Whenever a new row is added, what should happen? The agentic AI has to evaluate that particular answer and it has to store the result. So that is the main idea behind this one. So now what we do is we will connect this particular ASSN eval to our agentic AI system here. So that is what I will try to do. So give me a second. What is happening? Okay, I will select this one. I will double click on this Google Sheet trigger. And then I will click. I have already connected to my Google account. You just click on this create new credentials. It will ask you to Google password and all. You can do that one. There is no question about it. So here, what I will do is I will click on the drop down. You can see here, ASSN eval is created response sheet. So that is what I will select. Within this sheet, what is the thing? We need to select form underscore responses. That is the first sheet we need to select. So that's the reason I will click on this particular choose. You can see here form responses 1. That is what I will select here. And what is the trigger? Whenever a row is added, LLM has to be executed. So that is the trigger in this particular case. This much is enough. I will click on particular thing. And then I will connect this to edit fields now. So this is the input. Previously, we have taken the input from our you can say that webhook. Now we are taking the input from our Google Sheet here. Now in edit field, we have to do some more changes here. This prompt will remain same because end of the day, the question will be there, the rubric is there, and answer is there. So this has to be, the answer has to be evaluated based on the rubric, based on this particular question. So there is no question about this particular prompt. But what is required here is who has answered it, what is the email ID. I want to store those particular things also. So I will add another field here that will be name, and then the value to this particular thing. Again, it will be, you can say that the expression, I will show you what to be added here. We have to add something known as S1. What is that? JSON name. I have to get the name from the Google Sheet. So that is what I am doing here. I need another field That is email, because email, who has submitted this answer? I want to know that particular thing also. So that will be stored into email field. From where we will get it? Again, from sheet. So that will be added here. Again, it's an expression. I will store it over here. Now, we have done the set field. Set, what has that? We have stored our prompt in the prompt variable, name in name variable, and the email in email variable. So all those things were done. Uh, Now, it is executed. Mock output we will get here. Right now, we don't have anything. That's the reason we are not getting, because nothing is present in the Google Sheet. So I will do one thing. I will submit one sheet. That's the best option. So I will copy the link, shorten it. I will copy it. I will paste it. So just for understanding purpose, I will paste one fill one form. Let's say that I will put my name only. I will put my email ID here. There is no question. Question is CNN concept. I will answer it. CNN is image processing algorithm. That's what the thing. I will put a submit button. Now you can see here what has happened. You can see this particular sheet. In this particular sheet that has came. Now we have to execute it. So once we execute this particular thing, you can see running the set field. What the set field has got? The prompt it has got the name, it has got the email. That's the output of prompt edit field here. What LLM has got? LLM has evaluated that question and it has got the result like this. Total marks is 6, and it has given some different results based on that particular area and all. So this is what we have done. Now, what we have to do is we have to store this result into a Google Sheet again. What is that we can do in that case? We can click on this particular plus. Once I click on this particular plus, we have to select again Google Sheet. And then here we have to select pen, or we can say that the update row. Why? Because whenever a particular student has entered or submitted a form, this agentic AI will evaluate it. That will be stored into a sheet here. So that's the reason I have to select append here. And again, we have to select the account. And then account, you can select any Google account where the sheet has to be stored. And then what is the thing we are going to do? Append and update. Here we have to select what is the place where, or you can say that a sheet in which we want to store. So here what I will do is I will go back here. I will create one more sheet in this case because I want to store the result. So I will go to the sheets. I will create one more spreadsheet here. Here, I have to give some column headers, like where we want to store each of those particular things and all. So first one must be a time stamp. Second one here, it must be time stamp when it was evaluated or when it was added. Second one must be name of that particular student. Third one must be email. Fourth one must be evaluation. So what was the evaluation? So this is what actually I want to store. So when evaluation is done, when it is evaluated, what is the name of the student? What is the email ID? What is the evaluation? I want to store all these things. So what is the name of this particular sheet? I will name this particular sheet as result sheet. Results sheet. So in this particular result sheet, the result has to be stored. So I have created one new sheet here. So if you click on drop down, you can see this particular result sheet somewhere. We must have got the result sheet. Otherwise, I will click on this LLM, the sheet one more time. I have connected to this one. Result sheet, you can see here. Result sheet, I will select. Within that particular result sheet, this is the sheet number one. Within this sheet number one, I wanted to select it. You can see here how many fields are there. Timestamp is there, name is there, email is there, and evaluation is there. So here we have to put the prompts in this case. So what I have to do here is I will show you what has to be put with the timestamp now. So when it is evaluated, that particular time is now. So I have to put that particular thing. You can see here now has been added. That means current time. The name we have to get it from the previous thing. So I will put that particular name something like this. There is some problem will happen with the name. I will tell you what is that. This is name. The next one will be the email ID. You can see it is undefined. It is coming. I will tell you why it is coming. This is the next one is email. email is required for us in that particular sheet or the result sheet. In the evaluation is stored into the textual format text field. So I will put this one in the text here. So in this evaluation, I will put this text. Now you can see here, the time is coming perfectly fine, and the result is coming perfectly fine. There is no question about these two things. Okay, but the name and email are not coming. The reason is very simple. When we give this input to the LLM model, or whenever we give answer sheet to the evaluator, we should not reveal the name and email. So we have given only what? We have given in the prompt, if you notice here, we have given only the question. We have given only the, can say that rubric, and we have given only the answer. Only these things were given here. So that's the reason. What has happened here is, what has happened in this particular case is name is not present in this case. So that's the reason here we have to add one merge node. Merge means so we have to take some other things. So merge, it's a two things. So merge node, what it does? Merge node is the output of LLM is the one thing, and this is the input here. So what is happening now? So the set field, whatever the variables are there, they and the output of LLM is the answer to this particular merge here. Now, if you click on this sheet, and if you cross check it, we can see here now uh, name does not have any problem. I, I think it should not have any problem. If this is not the case, there must be some issue. I will just check it out. Name is still saying that is not defined. I will execute the entire workflow once. We will see what will happen. The column name is present here, but name is not coming here. Email, email. I just check it out once. If it is not there, we will leave it because it will take a lot of time to debug and all. But end of the day, this is how the thing should be working. JSON dot name should work. JSON dot name, JSON dot email. Okay, the reason may be this one. In this case, what we have used variable name we have used email, name and email. Okay, the reason is very simple. In this particular field, whatever we have entered, it may not be present. Okay, we'll do one thing for time being, because it is not working. We will do one thing. We will remove that particular merge, and then we will remove these two things also from the result sheet. As we don't have sufficient time, I think I will remove this particular name and I will remove this email. I just consider these things over here. I will remove this name. I will remove this email. So I will consider only this much, and then I'll try to execute it. Now you can see here, still there is some issue. Column names were updated after the node setup. Okay, no problem. That names were updated after the node setup. No issues. That's perfectly fine. This is how we can save it. I will save this one. Okay, so what has happened here is, if you look at this one, still the result is not coming here. Should have stored. Just give me 1 second time. I will try to check it out. Column names were updated. Okay, so I will select it one more time. Result sheet I have selected, and then refresh values. Okay, now I will evaluate it. Okay, still there is some issue. Otherwise, what I will do is I will connect it to some other sheet. Yesterday I have connected one more sheet to that one. I will connect and show you. Column match, column update. Okay, so I will show you the result, how it will be stored in this case like this one. I will show you the result, how it will be stored. In the yesterday's, I have shown something. This is stored some result here. Mahesh sir, how much time is remaining, or I have
Sir,
to stop
sir,
here?
we can take 5 to 10 minutes more, sir. No issue, sir. We can take 5 to 10 minutes.
The thing is, if the resource person is waiting, I have to stop. That's the
Yes,
reason I
yes,
was.
sir. Resource person is waiting, but you can still take 5 more minutes, sir. No issue.
Oh, okay.
Uh,
So see here, there must be some variable name mismatch or something like that. But if the names were given properly, I think you can see the result. Something like that, it will be stored into the result sheet over here. So you can see here timestamp, name, email, and evaluation. Evaluation marks are the strengths and all these things. This is how actually it will be saved. Maybe while doing that, giving the names and all, I have given some wrong names or something like that. That may be the issue. Otherwise, everything is fine over here. Uh, just give me a second. Just I will show you the yesterday's output so that you can see the things. Uh, everything is same. There is no question about it. This is how actually the thing I have built. Till here, I think I have built. Only thing is I have added these two more things. I will show you these two things over here. It will take hardly 5 minutes so that I will execute this particular thing because it was not working properly. Maybe variable issues were there. You can see there is two more modules I have added apart from this thing, result storing. The first one is something known as the Gmail. Another one is a Gmail here. So what this particular Gmail will do, or how we need to add it, we need to click on this particular plus. Again, we need to select simple thing. That's a Gmail. When you click on this particular Gmail, there will a lot of things are there. Add a label, delete a message, get many messages, and so on. So we want to send a message here. So that's the reason I have taken this one as a send a message here. So when you click on this send a message, we will get this particular email. Here you can see what is that I have written. Gmail account we have to connect. Again, without this Gmail account, we cannot send a mail. So we need to connect a Gmail account here. And then what is the thing I want to do? I want to send some message here. So what is the operation I want to send a message? So send is here. The next one is to whom I want to send. There is an email ID we have entered into that particular form. So that is the email here. The label is assignment feedback and then JSON name. This is the name of that particular student. This is the assignment field. That's just the subject I have added here. And then the evaluation report is added here as a message. So we have not done anything extra here. Just the evaluation message has been added so that it can be sent here. So that's the first thing that has been done. Another email component I have taken, again, email account we have to correct here. That's the first thing. Second thing is message then. This is a teacher email ID, you can say. If to teacher we are sending it, assignment evaluated, what is the name of that particular student, and the evaluation report. That is what has been sent at the mail here. So this is how we have added two more components in this case. Okay, so again, I cannot use the same form. I will do one thing. I will select some yesterday's form only. Assignment evaluation. This is the form I will use just to demonstrate this particular thing. So you can see a name, email, question, everything is there. There is no change. Maybe some variable issues are there. And I will delete the entire responses here just for uh, understanding. So right now we can see here there is nothing is present in the evaluation. Uh, there were some 11 responses are there. Now, what has happened here is we have created an entire module. This is a Google Sheet through which we'll accept the input. We have set the variables. This basic LLM will give that input to the graph model. What graph model will do? It will reason on the top of that particular question, rubric, and answer. That is the output of basic LLM chain. And this edit fields, name and email were combined or merged, and everything will be saved into this particular Google Sheet. And that report will be sent as an email to you can say that the student as well as to the teacher here. So this is the entire workflow here. And this is how actually we can see that the agentic or the agent, how actually agent is working and all. Now, if I click on this particular execute workflow, you can see here each of those things are executed one after the other. And then it is the result sheet I will show you. You can see here. This is how the results were stored. The name is stored. In the first case, email is not present. Second, email is not present. That's the reason email is not sent. But you can see here, the evaluation was stored into this particular sheet one after the other. So there were totally 11 responses are there in the thing. For each of those things, the result is stored in this case, 11 responses. Now, the thing is, I want to make this one as autonomous. So what I can do here is, I will click on this, what you can say that the execution. Okay. I will go to editor and then I will fetch it once. I want to make this one as autonomous. So what I will do is, I will click on this particular execution. Okay, so don't worry about this error. That error was coming because of that. You can say that our email was not found or something like that. Now, what I will do here is, I will try to submit one form here. I just check it out if whether it works fine or not. Definitely it should work. Just give me another 5 minutes so that I will finish this one. I will go to the responses and then the sheet here. Okay, I will delete all these things. The earlier one, I will delete it. Okay, nothing is present in our sheet. Now I will fill this particular thing. I will add my name, email ID. I can give some different mail ID so that it will be sent to that email ID. That should happen actually. CNN is the learning algorithm. And then I will click on submit here. Now, once I click on this particular submit button, you can see here there is one response has been saved. There must be one response here. And I will just okay, so that has been saved over here. This is the mail ID. Next, I will go to this particular thing. What should happen here is after a small, okay, you can see here, this is executed at this particular 19P2. This one autonomously. I have not clicked anything over there. It has executed over here at 1942-26. And if you look at this particular Gmail, you must have received one email over here. This is what you can see here. Assignment evaluated. This is the name. And another email, if you look at that particular thing, that is a student email. The student must have received the assignment feedback, so and so things. So what has happened over here is automatically this particular, whenever we submit that particular form, autonomously this particular thing was executed. So I will try to show one more response here. I will take the same email ID. I don't want to copy and type here. So I will take some name, different name here. I will take Prabhas. And then this one I will select. Just random answer I will write here. So don't worry about the answer at all. I will click on this particular submit button. So user has clicked the submit button. That response has been saved in this particular sheet. You can see here. Whenever this sheet has been added, one row is added, autonomously, I am not clicking anything. After 1 minute, what will happen here is automatically this will be executed. We have submitted around 7:44 or something like that. It will take 1 or 10 times delay, definitely. But it will execute that particular things. I think you can see here, January 6th, 1944-26. It has taken 5 seconds time. And if you go back and see the emails, both email ID I have taken the same. So I will refresh my email. You can see here, assignment feedback as well as evaluated feedback. Both have been sent over here. So what has happened in this particular case is, whenever in the execution mode, it has to be done. Editor mode, we have testing it. Execution means a real world example. So as and when a new form is submitted, the Google Sheet will be triggered. The variable will be set. LLM will execute that particular prompt, and then it will be saved into a result, as well as the email will be sent here. So the evaluation also, if you want to check, you can check that also here. That evaluation is also present in this particular case. So this is how actually we can build this the agentic AI kind of systems here. So if you follow this particular different steps, you will be able to definitely build this agentic AI. Actually, I thought to give one more example, agentic AI demo for two agents, but sufficient time is not available right now. This is the process what we can follow to build agentic AI systems. I have shown with the help of N8N system, N8N framework actually. I hope you got some idea. I may not be able to convince you entire thing, but you must have got some idea like how can we build the agentic AI systems over here. I will share this particular both the Word files, like each and every step is written, like what to be done, what to be clicked, and everything to the organizers. I will share it to my side. If you are interested, you can collect it and then you can try it out. I hope whatever the time given to me, within that I have simplified these agentic AI, different concepts, as well as uh, a few implementations, like how implementation is done. I hope I have done some justice to the topic given to me. If you have any questions, you can raise the questions. Now it's your
Uh,
turn.
Dear participants, you can unmute yourself, and if anything to say, you can tell.
There were no questions, then we can wind up, sir. The next
Sir,
resource person can take that.
Sir, thank you so much, sir. You nicely walked through agentic AI, starting from its definition, after that, patterns, architecture, and also you spread light on different tools available for agentic AI, that is low-code frameworks such as N8N, long chain, semantic kernel, also full code such as long graph, AutoGen, such kind of things. So I hope participants got some knowledge on agentic AI, and also the tools available. And the last section, you really put a lot of effort to make participants to understand how to build agentic AI, particularly single agentic AI, by making use of N8N. So definitely, this session is being that is YouTube streamlined. So at the end, I'm going to share the link. Those who have interest, they can watch the video three times, four times, because it is difficult to understand the flow and to set the variables, everything. So only after that, after trying for three to four times, they are able to understand these things. So thank you so much, sir, for your efforts, sir. Thank you so much.
Right, sir. Yes, sir. I will do one thing, sir. I will share this particular Word file. I have written each and every step by step, what to click, what not, what variable to be set, and everything. For
Yes,
these
sir.
particular two demonstrations, if anyone is interested, you can share with them, sir.
Yes, sir. I'll share that document to all the participants, sir.
Yes, sir. Yes, sir. Okay, sir.
Yes, sir. Thank you so much, sir. Thank you so much.
Thank you very much, sir.
Okay.
Shall I leave the meeting?
Yes, sir. You can leave the meeting now.
Okay, sir. Okay. Thank you.
Okay. Okay. Okay, sir. Dear participants, let us move on to next session, which will be taken by Dr. Shriram Kulkarni. Uh, Presently, the sir is working as a professor and also director of examination, Manipal Institute of Technology, Bangalore. Sir has completed his PhD from Vishweshwara Technological University, and also he completed postdoc from University of Central Florida, USA. Sir has 23 years of experience. He also worked as a project consultant AML in Mobile, where he has experience on developing AML algorithms for modeling stock markets forecast models. His areas of interest, that is key skills, are learning management system and artificial intelligence, deep learning, such kind of things. As a researcher, sir has published 50 plus international journals. He published his papers in journals such as Artificial Intelligence in Cybersecurity Theories and Applications, that belongs to Springer, and also he published a paper in IET Technical Review that belongs to Taylor and Francis. So in such a way, he published a number of papers in reputed journals. So now I request Dr. Shriram Kulkarni to address the participants. The topic is research trends and publication opportunities in AI.
Yeah, thank you, Dr. Mahesh, for the wonderful introduction. Right.
Thank you.
So I'll just share my slides. Is my PPT visible?
Yes, sir. It is visible, sir.
If there are any anomalies, please inform me.
Yes, sir. Just your okay, sir. Everything is fine now.
Yeah.
Yes.
Yeah, all the participants will be discussing a topic that is research trends and publication opportunities in AI. So this will not be a lot practical, it will be a lot of more of theoretical concepts. But we'll try to find something interesting in this, right? So we'll go with the basic definitions, right? So when we say what is meant by artificial intelligence and how does it trend to the future, like if you have witnessed that almost all enterprises, almost all part of human life is getting affected by artificial intelligence. So you can say it is one of the most effective technologies of 21st century. But as such, this artificial intelligence, right, though the term was coined somewhere in 1950s, right, uh, in the beginning of 1990s, it became something like there is no future for it. But one particular scientist, a professor from Stanford, was during those days working in Google DeepMind. He proposed something like he visualized that the future of AI would be in terms of supervised learning, and especially he thought in terms of scalable neural networks. And with that, the term deep learning came, and then all the success of AI that we see in the present era. So we'll begin with a definition of machine learning. It is a field of study that gives computers the ability to learn without explicitly being programmed. Rather than saying computers, we can say it as algorithms. Like algorithms can interpret the information on their own without human intervention. So that's a very interesting thing when we compare algorithms and machine learning algorithms. Machine learning algorithms can interpret the information without the intervention of humans. So the next thing that I would focus is about deep learning, right? And uh, these deep learning, as I said, are nothing but scalable neural networks. So it is something like a neural network with multiple hidden layers between them, and this addition of layers add to its complexity. And the most happening example of deep learning is GPT-4, and it's a massive transformer-based neural network with 1.8 million parameters. And the present GPT-5, we see something between 2 trillion to 5 trillion parameters. Can anybody explain to me what's meant by a transformer? Anyone from the audience, like how transformers revolutionized deep learning and how this open AI models like GPT-4 and 5 came into picture? See, earlier to transformers, we had recurrent neural networks like LSTM and bidirectional LSTM. These models could retain information, but they had a lot of limitations. But transformer could remember a lot of information, and this gave a edge in developing generative models like GPT-4 and GPT-5. Now, for all these complex machine learning and deep learning applications, we need a very powerful hardware platform, right? And if you see that the latest chip that is being proposed by the US tech giant NVIDIA is Blackwell B200 GPU, right? Graphical processing unit, and it's around 2.5 times faster in training AIs than its predecessor, and it has 5 times the power when supporting the inference. When we look at GPUs, we look at in terms of how quickly it can infer. When we look at its predecessor, right? The predecessor was nothing but Hopper. That is the most prevalent chips earlier to Blackwell B200 GPU or H100 and H200 GPU. So what it basically allows here is now it allows organizations to build their own LLMs, right? And it can also scale up to a trillion parameter large. So the LLMs, like most of us can't meet the scale of GPTs, but we can have customized LLMs in our enterprises and through a cluster of these Blackwell B200 GPUs. So now most of the times we see machine learning algorithms, but the question does come like, do we have any real world implementations for them? And there are two famous research agencies. One is Forrester and another is Gartner. So the principal analyst at Forrester, Mr. Mike, he said that there are at least some 8 key requirements for machine learning models to be developed, deployed in the real world. The first one is our model should be able to support, or our deployment should be able to support machine learning models created by different tools with their own inherent dependencies. Then it should provision the infrastructure needed for the entire machine learning lifecycle, right? It should also offer deployment freedom on premise, cloud, or edge, whatever the environment it gets. It should ensure that model governance to explain and audit model usage, like is our model working as per the baseline requirements. It should also ensure the model security and integrity, and it should retrain production models on retrain production models on newer data using data pipeline algorithms and code used to create the original. And it should support DevOps and machine learning ops professionals by supporting them with visual tools. And it should also have facilities to monitor the model performance and see that it is going as per the requirements. So if most of our machine learning ops satisfy these requirements, they can be deployed in the real world. So I've taken one example that is this is from the Forrester research. It is application called as Holiday Extras. And what does this Holiday Extras does? It helps us to optimize customer decision making. It helps us to release targeted advertisements, personalized customer experiences with recommendations. You might have seen other recommender systems like on YouTube or the famous piece of music you can listen. It helps us to automate the prices of services, and it also helps automated calls. So all these entire things are being done by machine learning models. Now there is something called as a machine learning proxy. As you know that client applications may be an app on a mobile phone, and there may be an artificial intelligence platform. So ML proxy is something which sits between them. The model that was used to develop the machine learning models was scikit-learn. And as you know that this will be real-time data that is being fed to the models for getting trained. So we need some type of pipelining and to develop models of such complexities where the scale of the models may increase or decrease. We may also need to come up with custom transformers. And finally, the model has to have the option to be cloned from GitHub. And it also needs to support model files and metadatas, which are again returned back to the Google Cloud Storage. And a model has to be evaluated because the clients can call with the right data schema. So with all these features, Holidays Extras came up with this architecture diagram. You can see that the ML proxy prediction service is sitting between the AI platform and the client applications. The prediction events are being handled by BigQuery. We have the Google Cloud Storage, and it is being cloned into GitHub. And Grafna is basically a visualization tool that is helping us to visualize the performance of the MLOps based models. So whenever we see research trends, the first preference I gave is for what are the industry trends. And as we have started the new year 2026, we need to see what are the how artificial intelligence will evolve in the coming year. So Microsoft has predicted that there are 7 trends to watch in 2026, and what it is saying here is like as I said, somewhere in mid 90s, the scalable neural network architecture boomed. And from there, for the present generation, they are predicting that AI will evolve as a partner. It will help us partner with humans. It will help to transform the work we do. And it will also help us to create and solve problems, right, across industries. So rather than visualizing a tool like GPT, which is very good in answering our questions, now we should start visualizing it will be collaborating with humans, and together they'll be amplifying their expertise. So this kind of transformation is already started being seen everywhere. In medicine, AI is helping to close in the gaps. In software development, it is learning not just to code but to even see the context behind the code. Means, is there any business logic? Did the developer took some security constraints into the mind? Did he had a particular system architecture thought while developing? So these generative AIs, right, or agentic AIs have already started visualizing these intents of the coder, and it's not just generating the code, but it is generating the code based on the relevant context. So if you visualize in terms of scientific research, the present generation models, you can visualize them as a lab assistant, equivalent to a lab assistant, helping you to strategize your research. As you know that the new generation, like from hype to reality, are our quantum computers. So our AI models are helping in terms of having a mix of classical logical bits, qubits, right, and trying to solve some interesting applications, uh, right. So we should not visualize. We should visualize AI agent as something like as digital colleagues, and they are helping humans to venture into new kind of developments, right. As I mentioned, the infrastructure powering these advanced also maturing. We just now saw that NVIDIA Blackwell 200 GPUs, right? So the first trend that will happen in 2026, as foreseen by Microsoft here, is uh, there will be a new era for alliances between technology and people. So we can consider this as the next wave of true collaboration. So people should not visualize that AI will replace humans. It is just about amplifying them. Like humans can become more productive by using AI as tools. So you should treat AI agents as digital co-workers. Uh, so you can Microsoft envisions a workplace where there is a 3-person team. So you have the AI agents, then you have humans who are steering the strategies, plus humans who are also involved in supplementing with creativity of work. So this is one of the trends that you'll see in 2026. Uh, the second trend here is when AI agents become collaborators and they start working with humans, the kind of security or the cyber security that we visualized just for objects, or what you can say softwares or clients or servers, now all those security constraints will also come with AI agents, right? So every agent would require similar protections as humans. Why do we need this? We need this so that we ensure that these agents don't turn it into double agents. Like we have the what you can say uh, mm, internal security risks, where a programmer within the perimeter, right, may intentionally or unintentionally destroy some data or compromise it. So we also don't want our AI agents to be such double agents. So we need to safeguard them. So what does this actually means? It means that agents have a clear identity. Like as humans, our usernames or logins, along supplemented with passwords, authorize or authenticate our identities. Then, based on the agent's role, we should emphasize what kind of information it can access and how does it manage the data and how it is capable of even protecting it from attackers and threats. So what all the humans would do in a development environment, the same thing we are expecting from agents. Now, what will happen here is at the same time, the attackers will also use AI in new ways. So rather than just thinking agent as digital co-workers, we also need security agents to spot those threats and respond faster. So this is in terms of security. Why all these precautions need to be taken? Because the bottom line, this is a very important statement. Trust is the currency of innovation. You should have full faith on the AI agent that it will work as per the directions of humans and the work that it generates can be trusted. So this is the second trend, that is securing the what you can say AI based agents. The third trend is AI is poised to shrink the world's health gap, right? So you know that humans will periodically suffer from many of the terminal diseases, and doctors with limited experiences or with higher experiences may not be always available to provide diagnosis. So AI is coming up as a very good, great tool to support these diagnostics, and it also helps in treatment planning. It is not just guiding you what medications to take, but it will also help to plan the treatment. So the World Health Organization projects that there will be around 11 million health workers by requirement by 2030. And there is still a gap of 4.5 billion people without essential health services. So we have a Microsoft tool called as Microsoft's AI Diagnostic Orchestra, and it has solved many complex medical cases with around 85.5% accuracy. And this averaged 20% more than the most experienced physical physicians. And already with Microsoft Copilot being integrated with Microsoft search engine Bing, Microsoft is already receiving more than 50 million health questions daily. And advances in AI will definitely give people more, what you can say, confidence in their own health and well-being. So this is the third trend that experts at Microsoft visualize. Then the fourth thing here is like advancement of science and technology is only possible through research. So, and what are the pressing problems in research here is like we need to model the climate so that our environmental concerns can be taken care. We need to understand the molecular dynamics. At the same time, we must come with newer types of materials that will make the design or will make the what you can say products more flexible and more nature friendly. So in terms of all this, agentic AI is helping a lot. So if you visualize somewhere around 2025, you would use AI to just summarize a paper or help you to write with reports. Now that's not going to happen. Now it will be actively joining the process of discovery in physics, chemistry, and biology. So AI will generate the hypothesis. It will help to conduct experiments in controlled environments, and at the same time, it will collaborate with both humans and it may also have other AI research colleagues. So the involvement of AI in research rather than just helping you to write or provide templates for research purpose, it will be actively contributing with humans to advance research in terms of climate, molecular dynamics, and material design. So you can visualize in future that most of the laboratories will have a AI lab assistant, and humans and AI will work in terms of pair programming, And as I mentioned, that this transformation promises to accelerate research and change how scientific discoveries are made. Now coming to the AI infrastructure. When I mean AI infrastructure, you can visualize it in terms of data centers, you can visualize it in terms of cloud infrastructure, you can visualize in terms of computing. As you know, the more powerful the processors, the more cooling requirements they have, the more power consumption it takes, and more amount of precious water is spent in keeping these powerful data centers and clouds cool, right? But how AI will help this? Uh, the most, if you visualize AI in terms of optimal utilization of infrastructure, AI will pack computing power more densely across distributed networks. You may have heard about something called as dynamic method dispatch, where the cores which have executed a process and which still have become free early, they can be assigned with new tasks so that all the cores of a CPU are kept busy and we can execute our programs in a very quick manner. So AI will be utilized for such applications where AI will utilize the distributed networks and see that all the devices are utilized for their fullest capability. And we can visualize these as more like flexible global AI systems. And what will be their main goals? Their main goals will be to down the cost and improve the efficiency. So AI will be measured by the quality of intelligence it produces, so not just its sheer size. So as I mentioned that computing power will be packed more densely and routed dynamically, so nothing sits idle. So as I was mentioning, if one job slows, another moves in instantly, so that we ensure that every cycle and every watt is put to work. So this shift will translate into smarter, more sustainable, and more adaptable infrastructure to power AI innovations on a global scale. So integration of AI into infrastructure will help us to utilize the infrastructure in a more optimal way, reducing the huge dependencies on power, water, and other coolants. Now, as I was mentioning, the sixth trend here is AI is learning the language of the code. That means it is interpreting the context behind it. So, how do you measure that? How much amount of code is being developed? You can see that through the interactions that happen with GitHub, version management software. So, right now, around 2025, developers merged 43 million pull requests, a 23% increase from prior year. So what does this tell? This tells that the amount of commits also pushed at the same time jumped by 25% year over year to 1 billion. Now, this is a very huge scale. And what does it clearly tells? It clearly tells that AI is increasingly becoming central to how software is being built and improved. That is, the amount of coding that is taking place with the involvement of AI is increasing day by day. So he says that the GitHub product officer says that by 2026, they are planning to incorporate something called as repository intelligence, right? So what does it means? It means that AI just not uh, understands not just the lines of code, but the relationships and the history behind them. So, but see, when you go for version management, it's not just version. There are multiple versions of software. So if the intelligent repository is understanding the relationship between the code and the history behind them, then this is a significant improvement, whereby the central hubs which teams store and organize everything that build, AI can literally figure what changed, why and how pieces fit together. So AI is collaborating with humans in developing a more realistic software on a repository. So what will be the net results? The net results will be we can catch errors if anything that is introduced into our version management and repository. We can even think of fixing the bugs the net result is the quality of software will be much better, and it also helps the developers move much fast. So in terms of versioning and repository, if the concept of repository intelligence as envisaged in 2026 will give a lot of competitive advantage to enterprises, whereby they can provide the structure and context for smarter and more reliable AI. As I was mentioning, the seventh trend and the last trend here is quantum computing, right? So nowadays you cannot just visualize quantum computing as a science fiction, right? So researchers are not entering a year, not decades era where quantum machines will start tackling problems that classical computers can't execute in a limited amount of time, as quoted by the executive vice president of Microsoft Discovery and Quantum. So, so lot of breakthroughs will happen, and the quantum advantage will be available to solve society's toughest challenges. So, what the difference now is the rise of hybrid computing. Like we have still not gone into the pure quantum era. We are still releasing. We are in the era of hybrid computing, where quantum concepts or quantum works will work with AI and supercomputers. You can just visualize like AI helps us to find the patterns in data. Supercomputers can help us to run massive simulations, and quantum adds a new layer that will drive far greater accuracy for modeling concepts like molecules and materials. So Microsoft's Majorana 1 already has made a lot of development towards more robust quantum systems. So it has the first quantum chip built using topological qubits, a design that inherently makes fragile qubits more stable and reliable. That's a pretty breakthrough. And it's also the only quantum solution engineered to catch and correct errors, which becomes very imperative in developing reliable quantum machines. So this architecture pave ways for machines in the future with millions of qubits on a single chip, providing the processing power that is needed for complex scientific and industrial problems. So the quantum advantage will definitely help to drive breakthroughs in materials, medicines, and more. So you can visualize the future of AI and science. It would not be just in terms of speed, it will be fundamentally redefined. So these are the seven trends, starting from collaborations to security, right, to medicine, right, and in terms of quantums, the trends for AI in 2026 is far promising. Now, the next AI-based research trend that is shaping is about explainable artificial intelligence, right? Uh, See, as I said, AI is touching upon every facet of human beings, right? That is in terms of it's still opaque, right? When we mean opaque in both in terms of providing AI systems, deploying those AI systems, and those affected by the use of the AI system. So companies provide AI systems, they help us to deploy the AI systems in the cloud, and users can use these AI systems. In all these three dimensions, AIs are still opaque. That means they are not transparent, right? And also in these complex realm of AI systems, even the providers of these systems are at sometimes they can't explain the decisions and outcomes of the systems they have built. So you consider the deep learning architecture as a black box. We have the inputs in terms of data set, what you can say, features, and we train the model through this black box, and some prediction happens. So this entire thing that remains unexplainable to humans, we call it as the black box effect. So if you want the AI to be trustworthy, you want it to be transparent, you want it to be accountable, and you also want it to be ethical, then explainable AI plays an important role in meeting this specific requirements, right? And this particular article, I've referred to the European Data Protection Supervisor scientific article, which embodies the explainable AI as a commitment to develop human-centered AI, right? And how does it envisage it? It envisages by explaining the why behind AI decisions. It enables individuals to participate in the digital landscape in a meaningful way. For example, by filing complaints if their rights are violated by AI-driven decisions. So in order for this to happen, the humans should be in a position to understand what led to this decision, and that's only possible through explainable AI. So one of the advantages here is the transparency provided by explainable AI not only strengthens the trust between organizations and users, but it also lies in core with data protection principles, right? Like what is the data being generated, how it is being used, and where it is being stored. And for all this, the human dimension remains essential. So as the transformative potential of artificial intelligence is embraced, it is crucial to use AI systems that can have profound consequences on individuals and society as a whole. So, in this context, AI goes beyond technology to combine AI potential with human need for understanding, responsibility, and ethics oversight. So we should not only focus on the technical capabilities of the AI, but we should also look at the humans' collective responsibility to uphold human rights, ethics, and accountability. So there are two dimensions of explainable AI. You can have either complex explanations or you can have oversimplified explanations. And there are lot of potentials, like this could lead to misinterpretations, like explainable AI if used incorrectly or maliciously could degenerate into persuasion exercises. Like we could use a malicious explainable AI to justify a system behavior, or we may also used as a protection for our trade secrets, which could hinder transparency. So the two paradigms of highly complex or simplifying with addition of malicious intent will hinder the transparency. And also the financial cost of explainable AI is profound, right? In some of the experiments conducted, it was seen that making AI systems explainable is undoubtedly expensive because they consume a lot of resources and a lot of interrogation about its explanation goes into the practice. So that was about explainable AI. The research trends would be in terms of ethics, understanding how the black box works, and what are its impacts on societal human beings. So these are some of the research trends in terms of explainable AI. The third paradigm or the third pillar which I would like to take is in something called as continual learning, right? Uh, this is a trend which was highlighted by LG company in its famous publications in CVPR, a very reputed conference. And the background here is like in 2016, we had AlphaGo, right? A version of the Go program, which is pretty complex, and it defeated a human being, and it was basically an artificial intelligence program, right? Now, since then, these artificial neural networks have continued to advance and outperform humans in a variety of fields. It may be image classification, or it may be in terms of natural language processing, etc. So, artificial intelligence has a lot of significance, right? And they are also great. These artificial intelligence models are also great in learning a single task and also striving to achieve better results. But now comes the question, like in human beings, like if you study, if you learn cycling, and then you learn swimming. That doesn't mean that once you learn swimming, you completely forget about cycling, right? So humans learn in a continual process. They go on acquiring new skills, but at the same time, they don't lose the skills or the knowledge they have acquired previously. Now, this is not so true, or this is the gap between humans and machines, right? Or you can simplify it as the ability to learn multiple tasks in succession. So even if humans learn a new task, right, they just don't forget the previously learned task. However, when we apply this to artificial neural networks, we have something called as catastrophic forgetting, whereby the majority of information about previously learned tasks is lost. So if our AN, an artificial neural network model, learns a new task, what all training it happened on the previous task is lost, or it's what you can say, unbalanced. So in an effort to narrow this gap, researchers started working on something called as continual learning, and this has been receiving a lot of attention in the past, resulting in a lot of publications in this particular area of research. So the first research proposal that came from LG Electronics was how convolution neural network models try to learn, right? Because they were the CVPR is more famous for computer vision papers. So they took an example of convolution neural networks, and so people started working with convolution neural networks for continual learning, right? But they also try to apply transformer-based models. So if you apply transformer-based models to vision, we call it as vision transformers, right? And the researchers proposed add-on to the CNN model. It was called as the dynamic token expansion. And this DITOX was mainly embedded for continual learnings. And what were their findings? Their findings was that these algorithms, right, uh, when extended with a CNN model, overcame the concept of catastrophic forgetting, right? And though each algorithm had the drawback, right? The CNN models had drawback, and they also needed a lot of hyperparameter tuning. However, when this DITOX was integrated with the existing algorithm, right, the transformer model characteristics with a relatively small model expansion, they outperformed all the existing CNN-based models. The second research finding they found was that self-supervised, or sometimes we called as unsupervised models, were much better in performance as compared to the supervised models, right? In terms of continual learning, right? So there are two papers in this field, right, proved that self-supervised learning suffered less in terms of catastrophic forgetting as compared with the conventional supervised learning using cross entropy, right? So unsupervised learning was more natural partner for this, what you can say, continual learning situations, right? So they also came up with a simple idea called as Castley, right? That helped further to overcome the catastrophic forgetting situations in unsupervised learning. And their experimental results proved that they could attain much better than supervised fine-tuning models. So as all of you know that there are a lot of research opportunities in unsupervised learning. If you club unsupervised learning with continual learning, it has a lot of scope to take the research forward in your future. So coming to the second part of our session, here we'll be focusing on what are the top conferences that you can think of publishing. One is Neura IPS, and as you know that they are very much renowned for research in neural networks and computational neuroscience. We have ICLR, a reading venue focusing on deep learning. We have ICML. It is one of the premier conferences for machine learning. Then we have AAAI, which is a major conferencing covering on all concepts of AI. And we also have a ICJAI, which is another significant on general AI. So these are some of the top conferences in the areas of uh, machine learning, specific on neural networks and AI. And in most of the renowned universities across the world, publishing in these conferences is treated at par or much better than some of the reputed journals. So I take a case study of NeuraIPS. It is like you can consider it as like a benchmark in conferences. And if any one of you envisage to publish in this, what are the strategies? Like this strategic document was prepared by the NeuraIPS committee, and this was like a guidelines to the researchers, like if they are trying to present it in NeuraIPS and publish in their proceedings, right? What should be the strategy? So they say that a significant fraction of NeuraIPS papers either describe or study new machine learning methods or theory. So your proposal should be quite novel enough, right? Uh, and while proposing this new algorithm, you should potentially describe a solution to a difficult application, or the one that proves bounds on errors of some learning method. Like you should hit the ceiling. And what are the expectations? The expectations are it should be significant in terms of algorithms, applications, or theoretical contributions. And NeuraIPS is very selective in shortlisting papers for the conferences, and their goal is to see that it makes high impact in the world and also in the research community and beyond. So they look at 5 criteria. The first criteria is novelty of the algorithm. So a paper that gives elegant new derivation for an algorithm or one that proposes a new approach to an existing problem is welcomed. The second part is what is the novelty of application or the problem, right? Has such a paper been little studied in previous NIPS conferences, or is it one that introduces a novel machine learning algorithm problem or proposes an algorithm for it? The novelty is visualized. The third criteria is what is the difficulty of the application? Is the application you're working is for a non-trivial system, or is it something like a NP hard problem full of complexity? What type of problem are you trying to address? Then the fourth criteria it looks at is the quality of the results. Like, did the novel algorithm you proposed demonstrated to give good empirical performance on the tasks of the problem considered? Did it work with real data and real experiments, uh, rather than just being artificial or using synthetic information? And where the theoretical results were as strong as the results that they achieved? Finally, the fifth criteria is like what insights does it convey? Like, were the general lessons learned? Were the mathematical or the theoretical tools that were proposed would be useful for future researchers? These all things are looked into, and if they satisfy these criteria, then the committee would definitely look to publish it in the very topmost conference called as NeurIPS. Now, if there are many budding researchers in this particular workshop, they should be familiar with certain concepts. One is called as the H index, that you see in your Scopus or in Google Scholar. What does this H index basically indicate? It basically indicates that the highest number H, where the author has H publications, each cited at least H times. So in this particular example, if the H index is 10, that means the author has at least 10 papers with 10 plus citations. If I have a 11th paper with citation 10, will my H index remain 10 or will it get changed to 11? Can anybody answer? I have 11 papers. My H index is 10. My 11th paper has 10 citations. So will my H index be 10 or will it be 11?
So, dear participants, you can unmute yourself and you can answer the question.
Pardon, are you a attendee or are you the moderator?
Dear participants, you can unmute yourself and you can answer the question.
Yeah. So I have around 10 research papers. I have 11 research papers. My 11th paper has a citation of 10 and my H index is 10. What does it mean? Should my H index be 10 or should it be 11?
10, sir.
Huh.
10.
Why 10?
If it is 11 papers with 11 citation each, then it will become 11.
Perfect. So if my 11th paper has a citation index of greater than equal to 11, it becomes 11. In this case, the 11th paper had a number of citations as 10. So the H index becomes 10. Now coming to I-10 index, it basically counts how many researchers have received at least 10 citations. So in this case, how many papers had, the 11th paper also had a citation of 10. So my I-10 count will become what?
It will be still 10.
It will be 11 because here it counts how many papers have at least a citation count of 10. So here in my case, the 11th paper also had a citation count of 10. So my I-10 index will be 11. But most of the time,
I was saying about the H index. It will be 10, but I-10 will be 11.
no, yeah, perfect. Your H index is 10 and I index will be 11, right? So I've just taken a snapshot of some of the top journals that are there, and this particular website had an what you can say a division based on the best scientists. Like, do the top scientists in the world publish over here? What were the amount of documents that were considered, and what was the cumulative citation? So these are some of the top journals in the world where you can think of publishing. Like, publishing means it cannot be at the beginning. During your entire research process, you should keep an ambition that I'll publish at least once in such top journals. Now, this is just a snapshot. Like, I will just share my experiences of how to write a journal article. The first one should come title. As you know that title should not be very small, like it just is an expansion of abbreviation. Or you may see certain publishers in field of basic sciences who write a very big title with very difficult acronyms. It should not be as complex as it is. It should be a balance between a very brief title and a very complex title, and it should also try to incorporate the keywords. And looking at the title, it should see that the reviewer or your potential readers, they should feel excited to read about it. Then next comes the abstract, right? This abstract, as almost all of you know, like it's like the core of your journal article, right? It's the heart of your paper. So when we used to publish it long ago, one of our mentors had said, there is, you write the abstract, you write the entire research paper, you write the conclusion, then again you change the abstract, because the abstract keeps on revising. So if you basically split the abstract, you have a general problem, that is the background. What are the pressing issues in that? What are the current state of algorithms or methods that are there? Where do they lack in terms of results? How is your proposed method having a potential to overcome it? And I would, my experience would be like, if you come with qualitative metrics proving that how your proposed algorithm is better than the state of art. Now, I'm not describing the entire introduction. I'm trying to give the gist for abstract. Because why this is so important here is, once your journal article is selected, the people enter your journal article just by reading the abstract. So by writing a very good abstract, you are advertising your journal article, and thereby the citation count or the interest of the scientific community in the abstract increases. Now, the there is a model called as IMRAD. So what does it indicate? It indicates introduction, it indicates methods, it indicates results, and finally it indicates the discussion. So what is the introduction? I would start with a fundamental background problem that is there in my research domain. And then I would say, like, why is this such an important problem? Then I would come with what are the best methods that are being solved to overcome this problem, and what are the difficulties these methods are facing. How novel is my research problem, research method or research algorithm that I'm proposing, and what are the promises that I hope to have. Now, this is not in a detailed manner, but this tries to communicate to the reviewer that the paper that is going to follow this is going to be quite interesting, and it's also going to add some new value to the study. Then comes the methods, and the method should be very clear enough. Like, you can have analytical, usually we call in the recent papers that we publish in AI and ML, we rather call this as materials and methods. In terms of materials, we just describe the data set that we have considered. For all the budding researchers, I would recommend that if you can collect a realistic data set and try to prove that a good decent data set, and try to prove that the process that you want in accumulating the data, analyzing it in terms of its dimensionality and other features of that data set, that makes it very interesting for your research. And then taking a similar data set from public data sets and then applying your algorithm for both the data sets and proving that what hypothesis or what data you set forth with your experiment and what is there in the public domain, your algorithm performed well in both the cases. This is what the journal reviewers expect. Let's imagine you came up with your own data set and it is quite interesting and your algorithm is also giving good results. That doesn't satisfy them. They say that, have you tried with these other data sets that are available in this? So for all the budding researchers, there is a journal in elsewhere which which focuses on the kind of data that you generated. You can just publish an entire article there describing your data. So an entire journal is dedicated for it, right? So this is about the data. Can anyone in the audience just tell me, like, you're working on a medical problem and you have only few records of the patient. Like, let's assume you got only something like 15 to 20 records. Like, maybe you're reading the brain signals or it's a complex medical domain and you got just 15 samples. But as you know that for machine learning algorithms, if you need to train, you need a huge data set. So these 12 realistic data, how can you transform it to a large data set? Can anyone in the audience tell me? Would anyone like to attempt it?
So through data augmentation,
Can you elaborate a little more? What do you mean by data augmentation?
that is, we have to change, that is resizing, or that is, increasing the
Well, can you go through some experience?
Yeah. Have
So
you heard about
we
these
have
we have to
generative adversarial networks, Gyan?
Pardon, sir?
Generative adversarial networks, Gyan.
Uh,
So using these GANs, you can take some few realistic records and you can scale this to any amount. You can even go up to 10,000, 50,000 or lakh. But the data set that is generated from these GANs, generative adversarial networks, we call them as synthetic data sets. Though they may be good to testing our algorithms for larger data size, right? But they are treated as synthetic data sets, right? So
I
this
I could not understand. So, what it means the synthetic data set is what?
Yeah, from the realistic data set, we are producing synthetic data sets using GANs. Because for some experiments, the amount of data that is available is very less. Let's imagine you have even something like 200 or 600 records. That may not be
Okay.
sufficient for machine learning algorithms, right? Because the more you train, the more the data you can generate, the more accuracy of the algorithm you can prove, like for testing it with some deviations from the training data set. Now coming to the methods you can have a mathematical model. Then we as computer engineers, we write algorithms. If you have a novel block architecture, you can put over here. You can explain the algorithm, right? And within the algorithm, if you have some equations which are novel enough, you can explain them more elaborately before you come up with the algorithm, telling how these equations are contributing to your new field of study. So all these will come in the method section. Finally, we come to the result section. In the result section, what all the methods that you proposed, you need to have equivalent results. And the results should be, what you can say, honest, fair enough to your methods. You should not try to hide anything. And also the values, I believe values up to 2 decimal places would be fine. Don't include results with values up to 6 decimal places. It becomes very cluttered. So, and your results should be explicit statements. It should not be very long explanation of what you achieve, because there is another section where you can incorporate here. Here your results should clearly justify the methods, and it should prove that all the methods that you describe, you have sufficient results to justify them. The next comes the discussion section. If you may be aware, after the results, you have got some results, but it's not necessary that only your results are the ultimate results. There may be other scientists who may have worked in the similar field. They might have different methodologies. They might have got results. Those results may have been something like they might have some limitations. So you took up this field of research, and in a way you're proving that your results kind of better than the state of art. So this should be captured completely in the discussion section. You can even put a table here. I do it in most of my articles. I put a table. I have the author name. I have the method that they worked upon. And I also prove what are the limitations, what were the advantages of their studies, what were the limitations. Finally comes my contribution, where I prove that I achieved something slightly better than what was done. And that's how, pay careful attention, we discuss originality in research. So when we say research, it's that delta finding which goes beyond the state of the art. Right?
So just a minute,
That's one way
I
of
would like to interrupt.
Yeah, please.
I have a question, sir. So in case, suppose I'm doing the things and following a method with the fair means, and if result is not favorable, and someone is using the method and doing some manipulations to bring the favorable result, in that case, how the unfair manipulation will be highlighted?
Can you just repeat? It was a little bit not clear. Please go a little slowly. Please repeat the question.
I'm asking, suppose two persons are using methods. In one method, the methods are very clear and transparent and fair enough, but the results are not stable. And suppose in another method done by someone else, he or she has incorporated some manipulations to bring the favorable result. So in that case, how the unfair tactics will be highlighted?
Okay, I'll bring here two distinctions. We'll come to this problem later, but I'll bring two discussions. We'll look into our ideal world. We'll not look into all these manipulations and fudged results. Okay, we'll look into the ideal world. So if you have the state of art algorithm and you propose your algorithm, if your algorithm is less than equal to the state of art, then some people question what was the major contributions of your research. So it is always good that if we come up with an algorithm, it should be at least what you can say, a little better than the state of art. That is acceptable by scientific community. Now, the next thing that you say that the results were, we'll not use the word manipulated, we'll use the word experimental setup, right? So in some experimental conditions with some assumptions, their results may be giving the reader a direction that they are superior to your work, but it need not be so. Your work is much superior because you have taken more powerful experimental setups. So in discussions, you can clearly write. Now, these guys considered only 100 records, but their features, their dimensionality was minimal. But ours is, please tell me.
But sir, in some cases, it has also been observed that in high quality experimental setup, uh,
Okay.
uh, 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 beyond using the natural data, some artificial data is also indulged to bring the favorable result. So, is it fair?
The last part of your question I couldn't get. Can you repeat it once again, please?
Saying कि in spite of using the natural data, some artificial data are being incorporated to bring the favorable result.
Okay. So your
in
question
that case,
is, yeah, I got it. Your question is like your experimental as original data and someone has taken synthetic data and trying to prove they're much better, right? Yeah. Now, one thing I'll tell you, when you go for journal publications, they always prefer realistic data. So under review circumstances, they'll give more weightage to your information or your data compared to the other person who has used synthetic data.
Thank you. Clear now.
Yeah, is it clear? Yeah. So
Sir, I have one question.
Yeah.
Sir,
Can
my
you introduce
question is,
yourself? Yeah, we'll come to
yes,
know.
yes.
Yeah.
Myself, Dr. Jay Bala. I have been
Okay.
working in GSET as an assistant professor for past 13 years. So my
Okay.
question is, when we talk about research, so at that moment I learned that research is all about that you take a moment and take a algorithm, whether it gives a right result, wrong result, whether it is positive result or negative result. So sometimes we even write a paper which will conclude that rather to take this path, researchers would have to take the another part to have a good result, right? But I could not see any kind of paper which would be having a result in a manner that is being published that it shows that this path that has ended somewhere. So we should not take that part to conclude for the application. So, what is, sir, your opinion about that? Because every journal is asking that our research should produce a good result, which is compared to the earlier publisher publish it, right? So it always may not be possible, right?
Yeah.
So, what is your own opinion?
Yeah. When we had started our research, maybe something like we got our PhD something like 13, 14 years ago, maybe 5 years prior to it, like let's assume go back to 20 years. Our mentors who had published in IEEE transactions and all, they would say that sometimes, even if, like you rightly pointed out, need not be, if there are 4 cases, we may get 3 good cases and 1 bad case, means the results may not be optimal. The best policy here is you should quote it as it is with a proper justification that this experiment under these circumstances, right, did not give proper results. I'll give my own experience. Like though I'm giving a talk on AI and ML, my basic PhD was in terms of networking. And when I was writing my thesis, like I developed a lot of knowledge in my field. And when I was looking at a base paper in my field, I started feeling that a very great professor who had written it had manipulated the data, because in my simulator version it was giving inferior results. But later brainstorming over that, I realized that I don't know his experimental setup. I don't know in depth of his experimental. So it is very wrong for me to say that his results are, like someone said, not up to the mark. So my opinion here is, even if you get some result which is inferior to the baseline, it is always safe to clearly articulate it, because there are two aspects to it. One is research should be reproducible. Someone who reads your paper should get, with the algorithm that you have proposed, similar kind of results. Second thing, it's not a trend nowadays, but in earlier days, the results in IEEE transaction would be also contested by people. And if they would prove that this author has not hidden that, or is not proposing it proper, this was long ago. The author would be requested to come up with a correction, or the editor would ask him for an explanation. So honesty is the best policy. That is what my take would be.
Thank you, sir. My another question to you, sir, that sometimes we have been asked that we should be having a comparison. So when we start comparing our work with the existing work, right? So what happened? Actually, the researchers that might have used a different data set, might have used a different parameter to tune, and then we compare our own setup with those results. Probably it would not be feasible to prepare the comparison, right? So at that moment, what we do? We are just taking the concept of that paper and we are implementing those algorithm or those model in our data set, and we try to compare and map that our proposed work is somewhat brilliant than the work that is being done by someone else, right? So is it a right method to have a comparison in deep learning or in artificial intelligence or in computer vision?
So in that question, I have an opinion. Can I?
Please.
I think, sir, in case of comparison, your view may be biased with someone. So rather than biasing your view, you must do your research work or the experimental setup or whatever very honestly, without caring of others' result. So that will be
Yeah,
the best
that's
one. That
yeah.
was
See, I'll tell you, in research ethics, honesty and presenting the results as it is are very important, because one thing you all should all remember, that the research that you do is for lifetime, and it may be contested at any point of time in your life. So, and a PhD degree is called as a terminal degree. That is, there is nothing beyond PhD. So you should do exhaustive work. You should be very forthcoming in your results. You should have all the
exactly.
results well articulated. If anyone questions, like that's how I did my research, you should be able to explain them even to the fourth decimal. That's about it. Now, coming to this question, if you look at a data set, you can think of its scalability in terms of the records, in terms of the number of features that it has. Like, let's assume a data set. Now, your algorithm has performed well for your data set. But see, now you're proposing algorithm means, in a kind of way, you're proposing a delta new better method in that field of research. So what the reviewers would expect here is, like, let's assume it's a diabetes data set. Now let us assume we have another diabetes data set with little more number of features and with little more number of records. If you apply your algorithm to that different data set, will your results be still good or bad? This is what the reviewers expect nowadays. Like, I had a Springer artificial intelligence journal with my research scholar, and we had our own experimental data set, but they said, no, we want you all to take a different similar data set in the real world or from any public data sets, apply your algorithm and prove that still you're getting the same good kind of results that you proposed. So that has been my experience in terms of reviewers.
Okay, thank you, sir.
Yeah. So we finish the discussion section, then we go to conclusion. The conclusion should be a mirror reflection of abstraction. That is, what all you claimed in the abstract, maybe in terms of qualitative. I always prefer quantitative rather than qualitative. Did you achieve all those goals? Sometimes people also write future scope that will be helpful to the new budding research. Now, I'll give a hint when you say future scope. Future scope should be something that is not achievable in the immediate future. it should be something like a far off goal, but at the same time you are presenting it like this would be the future of my research work. It's always better to conclude with it. Now, regarding references, see that you quote references which are of very good reputed journals, and then reputed conferences. If you are writing something like a review paper, right, you could also quote the book chapters, but people prefer more of journal articles and more of top conferences and book chapters and books. Beyond that, even web pages can be cited, but they usually don't prefer it. The reviewers recommend please remove them and cite with more authentic sources, because a journal, if you say a journal, it's a scientific contribution, and people would be happy to quote something from that rather than a web page or a blog which a person has written and for which there is no scientific foundations. So this was some of the tips for writing a journal paper. These are some of the references that I've used, especially for one of the references I got, the 7 research trends. It is something written by Microsoft on December 8, 2025. So it is the latest work that I've contributed. So almost my entire information has been from scientific journals and the industry white papers and all that, and Neura IPS and CVPR conferences. So all the industry white papers, industry-based research papers, my entire presentation has been extracted from that and no other resource. So I don't think I've prepared a slide for saying thank you, but if you have any questions, the young researchers, like, they are free to ask apart from what all we discussed.
Okay.
Good evening, sir. Good evening, Kulkarni, sir.
Oh, yeah, doctor. Yeah, Yogesh sir, please tell.
Yeah, so I had a question, right? Because I am also doing research. So,
Oh,
how do you, right, uh, handle stress when you're not able to get the right proper results in your research journey? So how do you get take motivation and then try to achieve
yeah,
whatever
yeah,
you're not able to get after doing multiple iterations of experiments? Still
yeah,
you're not able to achieve those results. So how do
yeah,
you think researchers should handle such kind of scenarios? Because
yeah.
you have traveled all over the world, so you might be right, also would have gone through these phases. So kindly
Okay.
highlight on how we can handle stress as a researcher.
Yeah. There are two aspects to your question. One is about handling results. Now, as we were discussing with other participants here, handling results is very important. Like, let's assume, I'll give a example. Let's assume we are computing energy optimization for 10 iterations of the simulation run. And in one instance, I have 10 records. In the second instance, while copying that record to my analyzer, I've just copied 8. So the next set of column will work more superior to one. So when you process results, take an average of your simulation run it multiple times and authenticate like what you've got is right. That's about the result part. Now, regarding stress, I can suggest something. I believe in a theory, my research journey or my belief is in terms of passion. Now, the research that I get engaged, when I get results, or when I start plotting the graphs, or when I innovate, I get certain kind of thrill. And I feel like I've really done something fantastic and I should be patted with. Means in my teaching journey, my research would always precede my teaching requirements. Like in my free time, I would sit doing a lot of research. So one is about theory of passion. So I would go with passion. Now the second thing here is, like you mentioned, like we are working lot of hard work we are putting, and we are not getting the results. Then definitely it will result into stress. We feel like, what are we doing? Like we are putting so much efforts, we are not getting it. But here I would quote one example, like which I had quoted in my earlier talks when I was a young researcher. Like if someone is learning swimming and he doesn't know, so you might have seen coaches, what they do. One day they pick up that kid or that person and just throw him in the water. And that person will do lot of movements and then he comes out. So almost all my research innovations have been an outcome of these extreme conditions where I've worked something I've not got. Like I would not say that I have never received paper rejections. I have received paper rejections, but I would convert that stress to a positive psychology and work double the efforts. Like while I was doing postdoctoral studies, I had submitted a scientific letter, but the reviewers thought it's a research article and they viewed it in that way. I felt really bad, and I just took a piece of paper and started writing equations. And I said by today evening I'll come up with a new concept. And by around 8 o'clock in the night, I had come up with a new model. Though it had crashed, I knew how to overcome it. And I had contributed something to the science. And I contacted my mentor saying that I've done something interesting and would like to share with him. So I would say convert stress to a positive attitude. And if you're putting 1x of efforts, convert it into 3x of efforts in a time bound manner. And say that till I get the outcome, I'll not stop with it. So in that way, you can handle stress. And definitely when you get results, all that stress, of course, it will have an impact on health and other things, but getting results is the most fascinating thing in research. So I would focus in that way. Yeah. I hope I've answered,
Yeah.
Professor Yogesh.
Yeah, thank you, sir.
Yeah. Any other questions? I think there is an interesting question which I expected the audience to ask, but if you have not asked, I'll propose it to you and I will answer it. Can someone define me what is meant by originality in research? That would be an interesting question. Like we all do research. Like what do you categorize as a original research? Would anybody venture into answering it? Here I will tell you there are three aspects. One is called as this original research, which I mentioned. Like we can consider it like invention by suit on the reinforcement learning algorithms, or the person who got Nobel Prize recently for his contribution for artificial neural networks. These are the people who wrote the original algorithms and methods. The second phase I would recommend here is applied research. What is applied research? Like recently we had a work. What did we do here is we took some equations from graph neural networks and we applied it to some research for some anomaly detection in our field. Like we were trying to get data corruption errors. So if you take a proven method in another field and that method has a potential to be applied to your field, right? And that when you apply it to your field, you get better results. That is also considered as research in our domain. We call it as applied research. Like if you look at the ant colony optimization, there was a scientist by name Holland. He took it from the traditional applications and he applied it to telecommunication network. And he published a great paper on it. So that is also acceptable. So either you can go for applied research or you can go for original research. Looking at the mathematical background and our context, getting original research at times is difficult, but applied research is a very great way of contributing to the field. So, and of course, like I mentioned earlier in my talk, all research should be a delta, what you can say, contribution to the existing field of work. Like you cannot propose something very new because we need people of that caliber to accept it. So almost all scientific contributions we do will be an extension of what is already known in the field. So this could be an interesting point to the budding researchers, right? Any other doubts, or we can?
Okay, sir. First, I would like to thank you so much for being with us. Thank you for your time, sir. Precious time. Actually, you spread light on different trends in AI, that is quantum computing, explainable AI, continual learning, such kind of things. Different areas where people can do research in AI. And also, you have shown some conferences, top conferences. So instead of doing some local conferences, it is better to publish paper in such kind of conferences. So I think that is useful for those who are doing research, and also for PhD candidates as well. And also you have shown some journals that belongs to IEEE and elsewhere. So and also I'm going to obviously I request you to share your PPT, and I'll share that PPT to participants later. Sir, thank you so much, sir. Thank you so much.
Yeah, thank you. Thank you.
Okay, sir. Okay.